various sectors. Secondly, national conference. It will be hybrid.
The kind of research that we do here,
Those who are able to attend the conference physically
is livelihoods. And I will
those who are not
maybe two
able
examples. One of the examples is
attend the
that
conference online,
I want to pick a
and it will bring together various partners of local and international partners, and it will be a good opportunity for various experts. These includes people from the industry, brokers.
This is committed to create some area.
Various experts.
So we relax them by
I would like to welcome all experts to the conference.
Once you extract the oil, this we remove the organic solvent and the oil now take it to further processing where we process the fatty acid. We have equipment which are doing the research here, which helps us to remove most of the organic solvent. This equipment is called a rotary equipment, which is this. And this unit, what you do here, you put the solvent inside like this, and then you rotate, come here and extract from a rotary system where
But also very
oil remains here. This is what we do to the last step.
Jomo Kenyatta University of Agriculture and Technology invites you to apply for degrees, masters, and PhD programs in the College of Engineering and Technology, COETEC. COETEC has 5 schools offering programs in the School of Mechanical, Manufacturing and Material Engineering, Electrical, Electronic and Information Engineering, Civil, Environmental and Geospatial Engineering, Biosystem and Environmental Engineering, as well as the School of Architecture and Building Sciences. The highly qualified, dedicated and experienced faculty at the college offer a conducive and participatory learning environment and is home to a diverse and vibrant student community. Over the years, the college has continued to produce competent, high quality and innovative graduates who have made significant contributions to various sectors of our economy. With state-of-the-art teaching and research infrastructure, coupled with a strong culture of innovation, the college stands at the forefront, facilitating the realization of Africa's development aspirations. Great stories begin here. You too can start your journey to making your dreams come true by joining JKU Art. Applications are ongoing. To apply online, visit admission.jkuart.ac.ke. JKU Art, setting trends in higher education, research, innovation, and entrepreneurship. Jomo Kenyatta University of Agriculture and Technology invites you to apply for certificates, diplomas, degrees, masters and PhD programs in the College of Human Resource Development. We are here to equip you for the marketplace. The College of Human Resource Development has 2 schools and 5 departments offering diverse programs in the fields of business, entrepreneurship, procurement and management, as well as communication and development studies. At the JKU Art Center of Professional Studies, we offer CASNEB, HRMPDE, and the KISEP professional courses. Over the years, the college has continued to produce competent and innovative graduates who have made significant contributions to various sectors of our economy. Driven by a strong culture of innovation, the college stands at the forefront of facilitating the realization of Africa's development aspirations. Our highly qualified, dedicated, and experienced faculty at the college offer a conducive and participatory learning environment and is home to a diverse and vibrant student community. Great stories begin here. You too can start your journey to making your dream come true by joining JKU Art. Applications are ongoing. To apply online, visit admission.jkuart.ac.ke. JKU Art, setting trends in higher education research, innovation, and entrepreneurship.
The project is basically about incorporating bio-based materials in the additive manufacturing process chain. And mostly we target local, that means Kenyan bio-based materials that are either underutilized or unwanted. Underutilized means some of them go to waste because we do not have enough uses for them. And unwanted means we do not want them in the environment. A case in point being something like water hyacinth, or maybe as was one of the recommendations from one of the meetings here at the university, a plant like Madenge plant or maybe cactus that are invasive maybe to agriculture or pose risks to both wildlife and maybe humans. One of the SDGs is about responsible consumption and production and consumption. And of course, sustainability means that we need to look at recycling, upcycling, and adding value to things that are either usually go to waste. And in our case in point, we try to create this sustainability in the plastic, recycling of plastics, and also incorporating bio-based materials in an aim to make the plastics biodegradable so that they do not end up in the environment as much as possible. In this project, we have collaborated both internationally and locally. Internationally, we have a project partner from Germany, and that's where we do some of the things. We share knowledge, basically, and we are able to realize the goals of the project. We also have exchange of both capacity exchange, so some of the members of our team go there and their team members also come here, and we get a technical and cultural exchange. Locally, we also partner with companies that are in the AM and recycling chain. For example, Mr. Green Africa, where we get all our recyclable plastics. And I agree with you that this is very vital for sustainability because we cannot expect that everything to come from either the academia or to come from industry. And so collaborations have, in this case, for example, we also have achieved equipment, and we have trainings, and we have people attached to this lab, all because of this collaboration. So collaborations are quite key and very much needed. First of all, I think that it's to understand that universities in themselves are usually home to fundamental information. So we need to look at different aspects, but there's only so much that we can do unless we collaborate with policymakers, with the industry, to ensure that if we get functional products, then we have a way to bring those to the market, or to ensure that we have a sustainable way of creating something that is economically feasible. So I would say that policymakers will play a big role because they can, for example, encourage this kind of innovations where there are incentives for when you innovate internally, and also then we need the industry to partner more closely with academia so that they are able to uptake, because maybe they have the infrastructure for upscaling this now to commercial terms. I think all the players are very important and are very much needed for a successful and sustainable maybe production. By having a closer interaction, I think one of the challenges, this may be my own personal opinion, is that most of the research that we do end up, as you said, in the shelves. And one of the reasons for this is because we do research maybe that is not very targeted to a specific societal problem that is here. So by
of our JQuat Scientific, Technological and Industrialization Conference, which is our day 2. Day 2 for the session, for the conference. And we believe that we are going to gather more even as we interact with the presentations today. So I acknowledge the presence of Chair of Council, Professor Micah Onsando. Karibu sana. Thank you for gracing this conference. We acknowledge our visitors, our invited guests, presenters, in whatever capacity you have come in. We also would like to specially recognize also the presence of our Deputy Vice Chancellor, RPE, Professor Kwanza. Karibu sana, and even for spearheading and leading us in this conference. This morning, we will be starting with a keynote address from one of our presenters who is not very new to us. I saw so many people greeting her because she's been here, Professor Muduri. Professor Muduri will be making a keynote address on agroforestry, a solution for sustainable livelihoods and resilient landscapes. Thank you, Professor Catherine Muduri, for availing herself for this keynote address or presentation. So Catherine, if I may just summarize, her background is an accomplished leader, project manager, researcher, and educationist. With a track record of excellence spanning 20 years, she holds a PhD in ecophysiology, agroforestry from this university, JKUAT. And she is the country director and regional convener for ICRAF. And of course, she has many, many positions. If we start, we'll spend the whole day. We know her area of research is mainly in agroforestry, water, food, people nexus, land restoration for improved food security and resilient landscapes and livelihoods. She's widely published, supervised several postgraduate students. She's worked on many projects. So she's accomplished in her area of specialization, served on several boards, and of course, we can't fail to notice that she has a presidential award of EBS, the Elder of the Order of Burning Spear. So help me this morning to welcome Professor Catherine Wangari Muduri to make her presentation. Welcome, Prof.
Okay, thank you very much, Chair, for the introduction. And it's great to be home. I honed my skills here at JQuat, and therefore I'm in familiar grounds. And I want to thank the leadership of this conference for inviting me to share my experiences. We continue collaborating with JQuat. So today, as it has been rightly said, this is the topic we are going to delve in. It's wide, it's broad. If you look at agroforestry and landscape, resilient landscapes and livelihoods, we can talk for long, but I'll try to just synthesize key lessons. All of us, agroforestry is an old, practice. Our farmers, our parents, in one way or another, integrated trees into their farms. Because agroforestry, we look at trees outside farms and in forest margins. And there are various ways you can see. That is in Ethiopia. You can see, trees incorporated across, wheat farms and maize farms. This is in Kenya. You find a lot of agroforestry on boundary as boundary planting. You can see this is using trees for timber, This is alley cropping where you have fertilizer trees. Gliricidia is one of the popular shrubs that we use. Here we have silvopastoral systems where we have livestock and pasture. And these are some of the long-term trials we have established to look at tree-crop interactions, because there is still a lot that needs to be studied around agroforestry. When we look at sustainability, we see how, livelihoods can cope and remain to thrive. It's important to note their ability to thrive as well as retain the natural resource base. And when we look at landscapes, I don't know what has happened. If you look at landscapes, you see when we talk of resilience, is that desired ecological functions and processes and profitability, maintaining that. And this is one of the landscapes where we are working in Makueni County. But during the rainy season, I don't know how many of you are familiar with Makueni County. During the dry season, one would think this is a very probably Professor Kwanza is more familiar with Makueni County and those of us who are doing research there. So agroforestry responds to many global challenges and plays a critical role. Now, if you look at deforestation and biodiversity, we find that about 50% of world's tropical forests have been destroyed. And that means many species are driven to extinction. We look at the climate crisis where it's predicted that temperatures will rise by 3 degrees by the end of the century. We have unsustainable, supply and value chain. Here in Kenya, about coffee systems, we know avocado and all the value chains we are having around, including timber. There is always an aspect of unsustainability. Then we look at transforming food systems where we have 2 billion people, who are experiencing food insecurity. And of these, 11% are undernourished. We also have a lot of extreme inequalities. And so agroforestry responds to these challenges and also addresses some of the SDGs, like, hunger. We have life on land and water. So SDGs 13, 1, 2, 3 are some of the areas that agroforestry addresses. In terms of Kenya, when we come back home, the government has pronounced itself to the 15 billion trees which are to be planted, and that will lead restoration of 10.6 million hectares of degraded land. And that is a target by 2032. And, a range of other things in terms of having improved planting material where we have 4K clubs, affordable energy, and that is clean energy by 2030, water management technologies, and reduction of greenhouse gas emissions. And this is not only our targets in-house, we have, addressing the AFR 100 targets and commitment by government. So why is agroforestry so important? And why should we have greater depth and understanding of the same? We did a recent survey on how agroforestry contributes. And I want to acknowledge Shem Kuya, who is the director research here, who alongside myself and others, we looked at an array of publications looking which an issue around livelihoods, carbon. And you can see all these are things that agroforestry can supply. fodder, food, fuel wood. If you go to the dry lands, even shade is a big ecosystem service that we get. And so in the work that we have done, if you look, 1 in 5 tree species are directly used in humans. So if you look at the species, you find that in terms of food, and over 7,000 tropical tree species have been recorded as used for human food. And of this, 71% actually supply have something to do with fruit. And I know if you look at most of us, especially a morning meal or at least a meal, you have to have a fruit in it. Yes, we desire to have a meal. In Rwanda, there is a policy in order to face, to address the issue of malnutrition and hunger. They have put up 3 trees per household and 1 cow, a policy on 1 cow per poor family. And you see, so we have timber. This is Milia vocensai, a very important indigenous tree species growing in the dry lands, and which we are working on with precious timber. And with Gatsby Foundation, we have a project where we are seeing how do we link the nursery and production and processing of that. This is fertilizer, leaves from Alna's acuminata from Rwanda, which are incorporated in as biomass. One would think that stakes for climbing beans is not important, very important. Research, I managed a project across the region, and one of the things which was reducing beans production, it was just having stake for climbing beans. Bush beans, the small beans, vis-a-vis the climbing beans, this is what we call climbing beans. Climbing beans produce 2 to 3 times more than bush beans. So you unlock the potential. We provided Acacia agostissima, we provided stakes from other tree species and shrubs, and farmers were able to double their crop production. Of course, firewood, honey, and we have dairy, which is a big thing. Those are some of the direct products. But we have services. One of the experiments we did in Ethiopia within the wheat farming systems in the Oromia region is that we found that wheat is able to, the ones growing under Phaidebia obida, you have a reduction. That is why we said wheat is kept cool. And that translates to production at the end of the day, where wheat productivity under Phaidebia obida is more. 1.5 to 2 times more than the one growing in the open sun. And we can talk about this in coffee systems, shaded coffee, where we have experiments in Uganda and have demonstrated the quality of coffee is better and the yields are higher under shade. And this is quite prominent even in Kenya. You have places like Murang'a, in Meru, where I come from, where we have a lot of these coffee systems which are shaded. Now, this is a photo showing restoration. We have been intervening in the Gisenyi area, Rubavu in Rwanda, and you can see during the rainy season, you'd have a lot of sedimentation. And after a lot of work and interventions, you find that the water, these photos were taken the same time during the rainy season in different years. After we had a project running from 2012 to 2021, and in 2018 we took this photo. Amazing what trees can do. And for those coming in the dry lands, we have carbon storage. Again, we in the same study, systematic review, we were able to show a lot. So how are we, using trees to ensure that we realize all these benefits? And agroforestry is a science. You can't just grow trees anyhow. Unfortunately, we don't have extension systems addressing how to grow trees. And that is where we have a problem. Now, we need strong evidence and science to drive. And just to share where we are convening. In ICRAF we have, in C4 and ICRAF we have so many, we are working in so many countries where we have gene banks and work going on. Why have work taking place in East and Southern Africa, in Western Africa, in Southeast Asia, in Peru? It's so that we can compare approaches, methodologies, and consolidate that for cross-learning. And when we come to gene banks, you find that all of us need seedlings. At the end of the day, at the end, the farmer will see the seedling, correct? You want to see the avocado seedling, but there is a lot of which is going on. Management methods. When I was here, I used to talk about, breaking dormancy as a physiologist. How do you break seed dormancy? How do you, do all those things to enhance performance of seedlings? And the whole thing, having the right tree for the right place, purpose, and people, then you need the right planting material. The other thing to look at, and which is critical, in my engagement with farmers, we look at why do farmers. I have appreciated social science more. As a biophysical scientist, when I left Jomo Kenyatta, and when I went to social science, and you have to manage projects, you need to understand what is the motivation of farmers be choosing between to do Grevillea robusta and to grow maize or French beans, where there are people who are, 1 acre of land, so many people are coming with different options. So how do you ensure that we have the right public and private institutional arrangements? So we do work around creating that enabling and business models that integrate smallholder farmers, especially in issues of dairy, where we have a lot and done a lot, even looking at fodder and how to integrate that into feeding systems. And then responsible finance initiatives, including carbon finance. And now the government has reviewed the Carbon Act, Change Act, and included carbon financing. That is one, and we are hoping that will be. So there are many value chains we are looking at, and depending on the context and where. Now, soil is life. Trees grow on soil. The medium is soil. You need soil health. Not only the biophysical, but you need the living soil. I remember having come from microbiology and working closely with zoology. Zoology look at the earthworms, bioengineers in soils. Those are critical to enrich soil health. So we look at the science, we look at the innovation, we look at the scaling, and we have done what we call the land degradation surveillance framework in so many areas. What the land surveillance framework helps, after you do all those soil analysis, then you are able to have a way of diagnosing where the problems are and how to address them. And when you are looking at soil, you also look at water. Now, the other thing is the climate crisis. And, we used what we call the nature-based solutions, which, provide around 35% to make it cost-effective in terms of emission mitigation. And you look at mitigation, you look at adaptation, and all these trees are important in terms of increasing tree cover, in terms of doing restoration, land restoration. And so climate change is not a standalone thing. But many times when you look at climate change or you say gender, cross-cutting issues, then you lose the science. So we have a dedicated unit when we look at methodologies and approaches around climate change. And when you look at this idea that 142 tree species are now extinct, it's not a very good thing. When we are doing restoration projects, and I'm leading a number, we ask farmers, why are you not growing this tree? And when we look at the vegetation, this tree grew in your area. And they say, we don't have seedlings, we don't have planting material. So our biodiversity is decreasing. We are using agroecological principles where you reduce inputs and you help the soil to regenerate, what we call regenerative agriculture. And all these are principles around fostering efficiency, harnessing, nature, and even the circular economy. And there is a whole coalition of partners working around agroecology, and ICRAF is one of the partners. And we are also having work in Makueni in Kiambu County, where we are working with partners to like showcase good practices and ecology. And I said, when you are doing to realize the hope, it's agroforestry for whom? And that's why we say options by context. Options by context means I can come to your farm, I come to the BBCRP and negotiate with him with 500, say if he has 10 acres of land. And we say, for him, I give him a cocktail of options. So this is a negotiation process to understand what matters to people. And why it ensures, it brings ownership, it aligns prosperity, and it builds and enhances on existing structures. Many are the projects you undertake, but because the process is as important as the product. You know? It's not the issue of saying end justifies the means. Is that the means is equally important as the process. And there is a lot I'll just say something about it later on. And then partnerships. When you do it alone, sometimes you don't have all it takes. What partnerships we are finding in our organization is that they are very critical, especially in ensuring that agroforestry is adopted and brought to scale. Why am I saying that? JKUAT competences are very broad. The department, research, as an academic institution. You also have a wealth of academic staff, and you have students, which we don't have. So the partnership that we bring is that you can bring students whom we can attach to our projects, and then we realize what we couldn't realize before. You can award degrees, we cannot award degrees, right? And therefore, if we build a partnership, so we leverage on investments, we consolidate impact at scale, and we minimize fragmentation. Currently, I'll mention about that project where we are working. And then capacity strengthening, especially of farmers. This is one of the lead farmers we are having in Kiambu County. And this farmer has transformed Githunguri County, Solomon. Solomon has been working with ICRAF from 2010. And he's one of the nursery operators we keep strengthening. And he tells me when from his home, he would see Nairobi. Then, but now he cannot see Nairobi because there are many skyscrapers and there are many trees which have gone in there. So this is important, especially when there is structured engagement, when there is reflective learning, and for university curriculum review and curriculum development. You still don't, Shem, do we have agroforestry course? When I was in botany, I don't know, the chairman of botany department, please, we need to finalize that curriculum. I acknowledge the former vice chancellor here, Professor Wanjohi, and when I left, we had started writing agroforestry curriculum. And I handed over that. It is important, and there is a project we were just doing with the Kenyatta University in the region using ANAFE. And we have developed an outline of the agroforestry curriculum. And I think that is something we can drive forward to have an agroforestry curriculum. You can name it, even include climate change. Policy engagement. ICRAF has been engaged in energy strategy development, current agroforestry strategy, and the agroforestry strategy we have developed also through the projects I've been working on in Ethiopia and Rwanda. We have guidelines, we have the forestry, farm forestry rules, and currently they are looking also at farm forestry strategy under KEFRI. We have the sustainable grazing strategy in Ethiopia. So for you to be effective, you have to inform policy. If you work and you are not informing policy, then your work ends at that. So I'll just, before I finish, I want to draw a few examples from the work we are doing in Kenya, so that it doesn't look theoretical. I'll draw my example from 2 projects. Actually, one of that we are working with JQuant, and this is funded by Australian Centre for International Agriculture Research, and we were looking at how to increase the right trees in the right place and potential for carbon. And we were working in Rwanda, in Bugesera district, and we were working here in Makueni and Kiambu County. And some of the things that came up were lack of quality planting material, limited capacity and knowledge. And you won't believe it, when we did this work, there are farmers who had, because it's a fruit trees project, there are farmers who had planted avocado trees and they uprooted because they had grown them using the wrong spacing. You know, there are farmers who don't manage their trees because they don't have the know-how. So there is a lot and lack of structured markets. And some of the key achievements from that project, we were able to realize actually fruit trees are over 30%, whether here in Rwanda or in Kenya, over 30% of the tree species that farmers put on their farms is actually fruit trees. Then capacity building, we have capacity built all this. And one of the things we are proud of is the formation of Gatondo South Avocado and Macadamia Cooperative. Because in the training, farmers were selling their avocado at the farm gate at zero prices. Individual exploited by men. I'm not an economist, but they are economists in the project. And what we did through the training, and working closely with Kiambu County, the Abomac started on its own after the training, and they decided they want to negotiate. And this Abomac, I talked with the chair, and he told me that now they are going to sell. And the membership started at 100, now it's at 800 farmers. They are even going to train others on avocado. We realize there is no extension on tree growing. And because Kefri has the app which they use on growing trees, when you are growing trees, you just a MITI app. We decided to come up with one, which is only Kuza Matunda. And all you need is to get it, and farmers are able to know which trees to plant and where, and pests and diseases, which is a big thing, because, you know, it's addressed there. And obviously, in terms of climate change, we were able to train youth. Shem with his team, they came, and they are able to determine simple way of how a farmer. We came up with an infographics where a simple way is a farmer is able to determine how much carbon their farm, especially in terms of avocado and fruit trees, is holding. And it was exciting because during the same training, there were people who are coming to buy, carbon from farmers. And the farmer said, no, after this training, we are not going to sell just like that. We need to negotiate further. Exciting. So you can download that app. Another project which I am doing on landscape restoration, very exciting and ongoing, funded by FCDO. The first thing is we realize there is a lot of fragmentation within landscape restoration. So many institutions are saying we are doing landscape restoration. So we approached the Ministry of Environment and Climate Change. That time it didn't have Ministry of Environment and Forestry before, and then now it has climate change, where the PS, the former PS Kiptor, helped us bring about 14 institutions. And using funding from ICRAF, we were able to have consultation across the 47 counties through 7 structures. This is one of, you can see there, Sosa is in Vihiga. So this is one of the county where we have the Lake region consultation. I think this one was in Isiolo. We had consultation in Isiolo County for the northern frontier counties. I can't remember, this is Machakos for the Eastern Bloc. And after that, we developed a trend analysis to landscape restoration. It summarizes the barriers to landscape restoration, the drivers to landscape restoration, and where the gaps are. And because we have Nature Kenya, we have WWF, we have KFS. KFS was part of that consortium, and so is KEFRI and the ministry. Everyone felt included. And then later on, we developed in the second phase, we had a consultation. And the chair of the governors, Dr. Otichilo, he's the chair of the COG in terms of Environment Committee, attended and has been working with us through the process. So we were able, one of the gaps of the county environment committees are weak. And so we developed towards stronger county environment committees in Kenya. And therefore, at the end of the day, we did county executive committee strengthening in Makueni County. We are doing one in Kiambu County next week. The other one will be in Homa Bay County. Those are the counties we selected in the first case. And this project is going to Laikipia County. And so there's a third phase which has been approved to Laikipia County. So this is what we realized. In Makueni County, because at the county level we worked a lot in Makueni County. You see, we realized so many people trek to get water, over 15 kilometers to get water. And sometimes it's not there. You find a dry riverbed. Now, this is the launch of these materials we have been able to do after the context analysis. This is a farm pond, you know, which is professionally constructed. We are looking at issues of clean cooking to reduce pollution. And these are nurseries we are establishing. In Makueni County, you know, if you are doing landscape restoration incentives like Zai pits, it requires a lot of energy. So food security was an issue. So we started the kitchen garden, which has picked up a lot. And when they have food, then they are able to do the conservation structures. And then we have a lot of material on gender transformative approaches and supporting farmers' innovation to restore. Now, so what are the barriers to landscape restoration? I want to finish. I can see he's telling me I finished. Policy regulations. Policy and regulations are big barriers. But I want to just say something about land ownership. Land ownership, if you don't have land ownership, you can't plant trees because long-term investment. And land ownership, though we passed land ownership for both male and female, I don't know how much that is happening. And knowledge and skills, this is a big gap. In the current systems, we don't have a, you know, environment is a devolved function. And when it is a devolved function, it is the responsibility of the counties to do the training, to do. That's why the counties we are working on, like Laikipia County, we are really excited. They attached 4 Governor Irongo's county. They attached 4 of their people to the project so that we can live, you know, the knowledge there. You know, knowledge and skills, institutional and market access. And here you can see drivers to landscape restoration, overgrazing, poverty, and lack of, in addition to food security and all that. So my recommendations would be that, you know, there are all these things which we have mentioned need to be addressed. And especially when you look at long-term donor and government funding in research trees. Trees take a we started a long-term trial here in Jomo Kenyatta. I don't know, sometimes it thrives, other times it goes down. Because when there is no funding, there are no students, and I was talking to the chair, botany, because that trial we started with the botany department. What happened? How do we ensure that that investment does not go to the drain? And a lot about seedlings. We want to make nurseries a business. And we are linking to KFS for them to get certification so that they can fetch good quality for their seeds and stock the right seedlings and grow them the right way. I am wondering, what is your role and what is mine? You can light a candle. How many of us have a piece of land or where you are living, you know? How many of us? I'm a teacher, I'm a lecturer. I'm a teacher, converted to research and working with farmers. Those are my, how many? Quite a number. How much can you dedicate even to boundary planting? This one we did on Red Hill Road. When Red Hill Road was constructed, the link road, ICRAF offered to support in regreening the link road. There are many places where the institution can actually, adopt landscapes and watershed. People are now adopting a forest, you adopt a landscape, you adopt a place. Gashororo, I don't know whether there is space for Gashororo, I don't know where, but you don't have to do it here. You can decide where to adopt and make the change that is so required. So I want to thank you for the opportunity. That is the end of my presentation.
Thank you. Thank you, Prof, for that interesting presentation, taking some of us back to our young ages. I remember for you to cut one tree, we had to plant two. Why can't we bring that back? You are talking about social sciences, how to deal with people. Probably should advise the government to take us back there, but in a good way, in a way that it will be accepted. And I've also taken note, COD Botany, I'll be waiting for your curriculum. At Dhaka, Shem, where is COD? I saw him around. Yes. We'll be waiting for your curriculum on agroforestry so that we can be able to take it up. Thank you for that presentation, but we'll just take a question or two for the sake of time. Our Chair of Council, Professor Nsando.
Good morning.
Good morning.
Thank you, Prof. That was a good presentation. The reason fruit trees can sell is because farmers can identify with the benefits. When you talk about ecological services, the indigenous trees are more robust than fruit trees. Ecological services. When you talk of business models and your biggest customer is a farmer, I accept a model where you say, this is how you have operated. We have introduced agroforestry, and this is the economics of that system of yours and our system. And for this area, these are the trees we recommend which can easily coexist with crops. If the farmer picks that they will make slightly more money in the introduced system, clearly you don't need extension. But I don't seem to see that. What I seem to see is a realization that the economics of this is important, but I've not really seen cases where, comparatively, a farmer can see value. Because farmers are very good business people, and they're a major customer of agroforestry. Yeah? So as much as we talk about business models, we really must make it simple. This is plus our system, and this is minus our system, and this is the economics. Yeah? That's one of my recommendations, or what I will wish as a Kenyan to see. When we talk about extinction of tree species, yeah, and we focus on fruit trees, then I think we are not solving that problem of extinction of fruit trees, of tree species, because crops can sell on their own anyway. Yeah. So, what are we doing in all this to demonstrate that if you go this way, you make better returns? Yeah. For Githunguri, for Murang'a, for Nyamira, for Kitui, etc., etc. if I was in a position to direct, I would really want a lot of energy to be put there, because that is how you can easily solve all this carbon, creation of carbon sinks, global warming, etc., etc., etc. I don't know what your take is on this.
Thank you. Just before you answer, so that you'll answer all of them together. Thank you, Prof. Nsando. We have Prof. Wanjoy there. You addressed your hand. We have, and then the last one. Yeah. Sorry, because of time, we'll not take so many questions for this session. Yes, Prof.
Thank you very much. And thank you, Professor Catherine Mufuri, for that brilliant presentation. My comment is on 2 or 3 things. One, I know the whole of Africa is focusing farmers, especially small farmers, on food production and food security. And definitely, once we do that, that is how to make sure that Africa will never feed itself. Why? Because you are still, one is still looking at small, a few plants, a quarter of an acre, and we call them farmers, producing less food than they can eat. They should eat less. And we are calling them, what are we calling them? Farmers. That is a misuse of the term. Farmers means large volume production of 2 things. And you remember yesterday we put it very clearly. 2 things. 1, food, which should not exceed 50% of farmers' production. The second one is production of raw materials. And if you remember, we emphasized forestry as a source of raw materials for building materials. Many clothing materials we have are from forestry fibers. Yet in Africa, we don't talk about it, because in Africa, we are not supposed to be making clothes at all. Didn't we explain yesterday? Because we are not supposed to make tools and machines, and therefore we are not supposed to manufacture anything for the market. It is suicidal. Suicidal. Please, when we talk of land use, let's talk of food on one hand and raw materials on the other hand. Most of the bananas we grow in Africa, we just pluck the fruit and then we throw away the rest of the material. Then we have to buy paper, this paper, most of which is made of, we have to import it, most of which is made of bananas. I tell you, it's so frustrating. So frustrating to see Kisi here. The whole land is bananas. They pluck only the fruit, the rest they cut and they leave it. It is very dangerous. And all this, we clarified, is a result of Africa being denied the right and the freedom to make tools and machines. That is the starting point of every development. Even agroforestry will never move in Africa if Africa does not resume making of tools and machines. Up to now, they are still denied. It is still banned in all African countries. It is still banned. That's why even our mechanical engineers, do we have mechanical engineers in this room? Where are they? That's why they don't make tools, even a pin. Have you ever made a pin? They have never made one. A pin. They don't even know how to make a blast for smelting iron. They don't know. Do you? He doesn't know. They don't know. And they are mechanical. They are very lucky. If they were here when Africans invented fire, all of them would be hanged. Because of contradicting the vow that Africa made, that Africa is the source of fire and making of iron tools, and so shall it be forever. That was the African declaration.
Thank you, Prof.
So, finally, now I have the final one. But I wanted to emphasize tools and
machines.
That's why even the dry area, they have the valley, that's what you have said. Yet it doesn't have water. Why? Because people have no tools for making the dams, so that when God drops water, the water does not flow to the Indian Ocean. Northeastern, they were crying the other day. There was too much water. They were asking God, please don't give us water anymore. And the reason is very simple. They don't have the tools for doing the dams. The people from Finland will tell you, in Europe, every river or every valley must have not less than 10 or 20 dams. They are here. And when you have those dams, even after the water flows, it doesn't go to the ocean. There is a system of pumping it back to the dam, automatically without using electricity. What's wrong with Africa? Navigation Act. You remember we mentioned it yesterday? That is the thing. Of 1651. And it is still the law in Kenya. It is the law in all African countries up to this day. When shall we be when shall we liberate ourselves? When? If this university does not lead that liberation, as we said yesterday, Africa will have to wait for another 5,000 years before we make a move towards development of Africa. Thank you very much.
Thank you, Prof. Thank you for that challenge to the mechanical engineers and the engineering fraternity. Briefly, yeah, and then Prof, you can respond to the issues raised.
Thank you, Madam Chair, Dr. Christian, and thank you, Prof. Catherine, for the presentation. Mine is a very brief one. As a student in this university, pursuing agricultural engineering, my interest is on sustainability in terms of agroforestry. You know, we aim through the SDGs to have a sustainable society. So my question is on the planting of these trees in terms of the planting of the fruit trees. We find the encouragement that is to the society is on planting them, but how sustainable do we grow them, and how sustainable do you have the end goal achieved, being that you find a lot of our fruits are invested highly on fertilizers and all these pesticides, and it is not really achieving the aim on sustainability. And also the next question on afforestation, based on the President, His Excellency William Ruto, encouragement on tree planting. But what about the information relayed and its practicality? I find like it's just taken into consideration but not practically done in an ethical way, where people are not informed about how do they plant, the spacing, the size, and you find like it is just taken as casually. Based on being in the ministry, your advisory to the maybe the task for the committee in charge of that, and maybe the practicality of us being going into the making a green society and having the whole reforms on afforestation. And also based on that, we find like many people are misinformed. We find we plant trees but we cut more trees, where even those which are planted are not taken care of. So that is my interest based on the presentation on agroforestry. But thank you, Prof, for the presentation, and thank you, Bana Chair, for the opportunity.
Thank you. Dr. Time. Okay, just the last one. But as you can respond as we wait for,
For those who have actually enriched from the chairman of the council, we don't, I'll just use an example of fruit tree in one project. When we talk about landscape restoration, that's why I say the right tree in the right place for the right purpose. So we have species for landscape restoration, we have species for fodder shrubs, all those. And the other thing which, and you have rightly put, when we do the baseline surveys, one of the motivations from farmers to plant tree is money. It's either income, and that's why fruits rank very highly. And that's why we took a conscious effort to address the issue of fruit trees in one of the projects, because in terms of carbon, they are retained. You don't have to push farmers to retain fruit trees on their land. They are retained for a lot of, so they can be used for carbon. But there was a gap, there was no how much carbon is sequestered in fruit trees. So that is just an example, but we give a cocktail of options which are fit. And that's why I used an example like Milia bokensi called mukau in Kikamba. Why farmers are not growing it, it's not because it is slow growing. It's an indigenous species valued by the local community. And now with Gatsby Foundation, we want, because they are doing the processing of timber, then we can link the production side, as Prof have talked about industrialization, to, so that it is a whole systems approach from production to processing. For example, we have in Makueni, we have a mango processing factory, and at Kalamba. Now, there is a disconnect because some of the varieties of mangoes which farmers are not growing are not accepted in the factory. Yet the farmers have started growing the avocado. So I think when you look at the whole value chain with the right partnerships, then you get things right. And ICRAF is about tree diversity, but having also the incentives that are required for more farmers to take that up. Yeah, thank you. Yeah, yes. Okay. Yeah, so that profitability, we have the markets people, and that's why one of the aspects, because we work across a transdisciplinary team, so there are people who look at the value chain and the market, so they are able to quantify those things and therefore give a business case, because you have to provide a business case in decision making for the farmer. Now, the other question by Prof is about industrialization and why smallholder farmers. Now, this borders on policy. When you are going to intervene in smallholder farmers, we are finding farmers with even a quarter piece of land. We cannot change that for now, because land fragmentation is one of the challenges to food security. And in Rwanda, there was a policy on land, consolidation of land. And it worked, where they consolidated land for food security, for growing fruit. But when I go to a farmer who, by the way, wants food on the table, wants firewood, wants all those things, I cannot dismiss them. I have to work with them and provide solutions, even as the political class and, the higher people get solutions, because at the end of the day, it's food on the table for that farmer. And so we provide practical solutions, and we don't live without showing the value chain and the benefit. But what you have put a handle, which is important, is mechanization. One of the challenges, and I throw it to you, when you can't have dams everywhere, and if you ask a landscape ecologist here, or what are they called, engineers, the BED, it is now it's called agricultural engineers, and whom we are working with, you have to increase the ability of the soil to hold more water. So there is a place for dams, there is a place for rainwater harvesting, and there is a place where you teach the farmer on good agricultural practices, where they start and they harness the ability of that soil to retain more water. And it's exciting to know we shouldn't be just at the raw material state. I agree. Industrialization is where we should go. And when we are doing those Zai pits and all that, we need mechanical engineers. My daughter did civil engineering here. And I asked her, how can you help me make Zai pits? Create a small implement which farmers can quickly use, because we are requiring that on land. They started with the one young man, but they are yet to finish that. That was a task. So engineers, please give us those innovations. I like the question you have asked about what we are doing in innovation related. Now, tree growing is a science, and survival rates are very low in the drylands. And that's why in the drylands, we also need to be talking about farmer-managed natural regeneration. It's not a one-fits-all solution. So in farmer-managed natural regeneration in the drylands, you are able to get fodder. We are doing enrichment planting with grass. And cows are thriving there, and goats are thriving, which is a livelihood for those communities. And you don't have to push that agenda, because that is their livelihood. So, exclosures, farmer-managed natural regeneration, and the tree starts growing, and you have a lot of fodder grass. So, yeah, and that's why they started the Jaza Miti app. How many of you are aware of the Jaza Miti app? How many have used? Because according to the President and the Ministry of Environment and Climate Change, we are supposed to plant trees and record it in Jaza Miti app. So you can download the Jaza Miti app. When you plant, you record. We have a lot of information and manuals, if you go to the ICRAF website, how to grow trees the right way. The size of the hole, it's amazing. Sometimes it's saddening to see all these drives of tree growing when somebody just uses a djembe, remove some soil, and plant a tree. It will definitely not survive. So there is a lot. And then, so now I think I've responded to that.
Thank you.
Yes.
Thank you.
Parliament, you have the duty to repeat to examine the land, private land ownership sites. And then, put it in the manner the definition of the sense for the country. Two, make sure you don't allow people to use the land the way they need. It needs to be organized for economic development of the country. Article 68, it is there. And even of the dry land. What here is in dry land is true. But the water in the whole of the county is only 40 days. What is dry land dry? It is not dry. It is a lack of equipment to get that water to the top and make the whole of Northeastern green. And forest.
You are right. You are totally right, Prof. Prof is right, but we work in the framework on the county governments, which when you go, there are a lot of things to navigate within the county government. So the political landscape and the counties that you work in, there is role for government, there is role for county, but when you intervene together with the county, we will do something significant in Laikipia. Because Laikipia, they are digging boreholes. So it depends on the county you are intervening and the enabling environment there. Yeah.
Thank you. Thank you, Prof. Dr. Mangira, kindly allow me to, we'll have her around. We can ask her more questions after this. Apologies because of the time limitations. Let's give Prof a hand clap. I would like to invite our DVC RPE to present a gift to our Prof here to recognize her for creating time to come and share with us. And please, she's not going away. I hope you're still around. I can see people want to ask you many questions. So be ready for those questions after this in the other sessions. Thank you. The light is on there. Maybe move to the end. Yeah. Let's give a hand clap. Dr. Shem Kuya would be coming up here to give us guidance on the next, what is coming forth. Thank you, Prof, and for that inciting, taking us back to the reality of making sure we have trees grown in our country. Yeah.
Good morning, all. It's a pleasure to have listened to the keynote speech, and the next session will be transitioning into the breakout rooms. Yesterday's keynote speeches were so interesting, and they took more time than what we had anticipated. And so I have some information on guidance on how we'll break out into the groups. So all presentations that were scheduled for yesterday afternoon were moved to today. And so for the physical presentations, session 6, Basic and Applied Sciences, and session 7, Agriculture Science and Technologies, have been moved to today, and then combined with the similar sessions of the so if it's agriculture that was to be done yesterday, it's been moved to the agricultural session that was to be done today. And then for engineering, for advances in medical and veterinary sciences, this session will be virtual. The rooms have been opened, and it will be combined with session 14, advances in medical and veterinary sciences. So session 8 and session 14. I'm just mentioning this, but all participants and registered people in the conference have received this information. And then engineering, build environment and infrastructure, that was scheduled for 11:30. Now will take also place in the morning. And that will be combined with the session 13 for the engineering. Now for the virtual presentation, the engineering information technology will happen in the afternoon, and session 9 of engineering will happen at 11:30. I think this is how we'll move. If you miss it, kindly consult the email. And so agricultural sciences will remain here in terms of rooms. And then we have room 2 for basic and applied sciences, and then room 1 for engineering. Thank you. So agricultural sciences remain in the assembly hall. Thank you. So we can break out to the groups. Thank you.
And now, first-hand getting the problems, we can more closely work so that we can tailor our research towards something that is solving a need for them, because then this is a mutually beneficial situation, and that way then the funding will follow. Because some of the challenges that we also have is that we have not enough funding going into research, and maybe that's also a place where the government can, which we know that it's already doing something, but that's something that we can even work more closely to ensure that we advance. Yeah, so my parting shot to the participants of the 18th JQuad Scientific Conference is welcome to JQuad, come and have fun, exchange ideas, especially for the scientists. Let us learn from each other, and let us be open to both networking and also looking for solutions to ensure that JQuad continues to remain a leader in both research and innovation for a sustainable future. Thank you.
We have developed a number of machineries. We have been able to develop a stirrer that is used for mixing detergents that are also used for making soap. We have deployed that in improving the quality of soap. We also made a dehusker, a very important tool, very critical at the beginning of coconut processing.
The kind of research that we do here impacts directly in communities' livelihoods. I want to pick a project that we have conducted in Kisumu County. What we have realized based on our previous projects here, that we have collaborated with the Foundation for Innovative New Diagnostics and the Ministry of Health and counties, is that there is a major gap, especially on diagnostics. But our work has indicated that getting these diagnostics at level 2 and level 3, that is in dispensaries and health centers, is very, very difficult. You only find them, these profile tests, ANC profile tests, in a few level 3 facilities, but not at level 2 facilities. Then this forces women to walk very, very long distances, therefore spending a lot of money on healthcare, for transport, and even realizing that they take a lot of time out of their regular schedules. And we know that pregnancy is not a disease ideally. So this is very, very important, and I would want to use it as one of the examples where we have a project that impacts directly on the community, and it helps. Of course, during these projects we also put students on board. So we have, in Kisumu, we have an MSc student. In our clinical trials in Kwale, we have 3 PhD students and 5 MSc students. So again, building young, scientists to learn the ropes of research, and this is very helpful. Yes, I think one of the biggest gaps that exists between academia and industry is lack of coordination. Lack of a coordination mechanism. I think the two can work symbiotically to support each other. If you look at the West, most of the innovations that industry is able to scale up comes from academia and research institutions. And it will reach a time in this country, based on what we are realizing the wage bill for national government is, that if industry does not invest, if the private sector does not invest in academia and in research, some of the institutions of higher learning will be highly unsustainable if the central government cannot support them. If you realize, for example, NASA, if you realize, institutions in the US, the ones that are involved in space exploration, development of very, very, important engineering solutions, it all starts at the basic science. Now, what has happened is that our own country, our own government, does not put money in basic sciences. The West does not do that for us. So we are left mainly with implementation science and maybe clinical trials, which is clinical research, which you are testing compounds and solutions that are already developed. Now, running away from what ourselves, we have an opportunity for, for development. So for the scientists that will be attending this conference, one of the important things is the fact that as we develop ourselves as scientists, as we nurture young scientists or younger scientists, we have an obligation ourselves. It is part of why we benefited by being trained. It is time that we utilize our intellectual capital well by serving our country in training and nurturing young scientists.
The Jomo Kenyatta University of Agriculture and Technology invites you to apply for degrees, master's and PhD programs in the College of Pure and Applied Sciences, Corpus. The college has 3 schools offering programs in the fields of computing and information technology, biological sciences, and the School of Mathematical and Physical Sciences. Our flagship programs offer competitive, industry-driven training, and our graduates are leaders in the marketplace, currently offering innovative solutions in diverse sectors of the economy, both locally and internationally. JKU Art is currently the only university that offers Bachelor of Science in Operations Research in Africa and is also amongst the 3 prestigious universities within Africa that train Bachelors of Science in Financial Engineering. The highly qualified, dedicated, and experienced faculty at the college offer a conducive and participatory learning environment and is home to a diverse and vibrant student community. Over the years, the college has continued to produce competent, high-quality, and innovative graduates who have made significant contributions to various sectors of our economy. Great stories begin here. You too can start your journey to making your dreams
Good morning, everyone.
by joining JKU Art.
I want to call us to order as I look for my rapporteur.
Visit admission.jkuart.com.
Oh, she's coming. Yes, please. So as we wait for the rapporteur to come, I would want to make 2 communications. One of the communication is that as you are aware, we have combined yesterday afternoon session and this morning session. So we have a total of 12 presentations. So we expect a total of 12 presentations. We also have a request from the group from Maseno University who are supposed to be presenting yesterday. They have requested they'll go first. So if you find that your name is probably the first on the list and we've not called you, please understand, we'll start with the Maseno group. They have 3 presentations. So they'll make the presentations first, then we continue. They would want to leave a little bit earlier to get back home on time. Okay, so thank you and karibu. So I want to start with introducing myself. My name is Peter Kahenya. I'm a food scientist by training from the Department of Food Science in JKU Art. I want to take this opportunity and once again invite you to this session on agricultural sciences and technologies. Agriculture is the mainstay of our economy. It's a very key sector of our economy, and therefore research in agriculture is very key for the growth and development of our country and our region. And I want to, without taking a lot of time, I want to invite the first presenter, who is going to be, I presume, Esther Gonga, who comes from Maseno University, and she's going to present on the role of multi-actor communities of practice in dissemination of push-pull technology. So I want to welcome Esther to come and make her presentation. Esther? You have 10 minutes for presentation and 5 minutes for question time. So kindly try and fit within the 10 minutes. At the 8th minute, I'll knock on the table as a signal that you have 2 minutes remaining. Thank you. So Esther prepares to present. Her co-authors include Benjamin Obok, D.O. Osewe, Frederick Aila, George Othiambo, Winnie Oliech, Dennis Mulupi, and Cosmas Kiprono. Maybe in the interest of time also, the next presenter will be Cosmas Kiprono. So Cosmas, kindly ensure that your presentation has been loaded before, or you make sure you liaise with the media team to have your presentation loaded so that we can start on time. After that, we'll have Dennis Mulupi will be the next presenter after Cosmas Kiprono. Then we'll go back to, so that you can plan your presentation, to Gidafaye Achamu, followed by Lidambiza Muhandale. Then we'll have Githui Frederick. Then we'll have Sylvia Buletti, Rahab Mbai, and team. After that, we shall have Elisheba Ibaya, Garrison Kiprotich, Damus Wanjiko, and Collins Kaisha will be the last one. So once again, we shall have a 10 minutes presentation and 5 minutes of question time.
Okay, good morning. Good morning, everyone. So my name is Esther Ngonga from Maseno University. I'm here to present on the role of communities of practice in dissemination of push-pull technology in Western Kenya. So Agriculture is one sector that usually helps us in food security, and in Western Kenya, most of our rural households rely on maize production. So maize production is the main source of food in these type of areas, and maize tend to encounter a lot of problems in these areas, and my main aim is focusing on the biotic stressors. That is the striga weed, the stem borer, and the fall armyworm. So as you can check the first photograph, we have those farmers and the striga is all over those plots. So most of the plots in Western Kenya are experiencing striga. Striga is one crop that it can take time over the years. The seeds are underground to an extent that when it germinates, a lot of seed has already banked inside the soil. Second photograph is showing us the stem borer and the fall armyworm. These are some of the pests that have affected most of the farms, and they are giving farmers stress on how to manage them. Remember that fall armyworm came in 2016 in Africa, and it spread in Kenya in 2017, to an extent that in 2017 we had to import maize from Mexico. So there is this technology that was brought about by ISIPE. That is push-pull technology. In as much as it has taken over 20 years, but some of our farmers still don't know that this is one of the technologies that can be used to control these problems. So push-pull technology, this is an organic method. And in this type of technology, we are cropping a legume. We have a cereal crop. The legumes are there. They are helping us to repel this type of pests. And as a result of that, we also have as the border. So at the border, these ones will be pulling away the about method. Push-pull technology has evolved. We had the conventional where we were using the napier grass. At the same time, we had the climate smart that had the silver leaf and then the mulatto. So this push-pull technology is very important technology, but our farmers have to be aware of it. And there is one way that our farmers will be able to know about these benefits. Push-pull technology has a lot of benefits. As we can see, most of the plants uses nitrogen fixation in form of nitrate. These legumes that are involved in this technology are helping to fix the nitrogen. At the same time, the soil health, which is very important for the plants, is very key. Also, we have conservation of biodiversity. Remember, push-pull technology, you are not going to use any chemical. You are going to use the biotic organisms to control this type of pests. So in as much as we have this technology, we have to get strategies on how farmers should know about this push-pull. So under the upscale project, we have the stakeholders, which we are calling the multi-actor communities of practice. We have at the center there, we can see that we have knowledge sharing and capacity building. We have different organizations that are supporting push-pull, but having a structured forum where all these stakeholders can come together to share their ideas will be able to make the farmers to know that at least if they come together, we have dissemination pathways that are not conflicting to each other. That way, the farmers will be able to know that push-pull technology is a very important technology. So we have the extension providers, researchers, we have the upscale partners who are around 17, we have the government and policy makers. All these people need to be brought on board so that we know that we have better ways of ensuring that we enter the future as researchers together. Remember, research is something that is jointly done, but not an individual work. So these research focused in Kisumu, Siaya, Vihiga and Homa Bay counties. Those are counties that are focusing on upscale project. And our main focus was on the effects on the multi-actor community dissemination on push-pull technology. We sampled a number of 304 farmers proportionately on these counties, and we used semi-structured questionnaires for data collection. The data analysis was done through descriptive statistics and were presented in form of pie charts, graphs, and tables. So in terms of the results and discussions, This survey showed us that at least 77% of the farmers were aware of the push-pull technology. And that is kind of impressive because if we bring more multi-actors on board and we have a shared idea forums, we'll be able to make farmers know about how to control the problems of maize production. So in terms of the multi-actors awareness, because we had to know if farmers know about the stakeholders in that field, we realized that the research centers, ISIPE, universities, NGOs, and government extensions were leading because, remember, this push-pull technology was developed by ISIPE, and they tend to do a lot of work in terms of demonstrations and fieldworks to ensure that farmers get more information. Farmers and farmer groups took the second position at 18, but social media, which is very common with our youths, took the least, because if we involve the youth in this kind of opportunities and forums, then they'll be able to project to the social media instead of whatever they usually post the content. They'll develop contents on push-pull technology for the farmers to see. We had the impact of market engagement. We dealt with 304 farmers, and in terms of awareness, at least 48% were aware of the stakeholders. And we have these activities that are usually organized by the multi-actors. So at least 70% of those activities, those farmers who knew about the stakeholders were aware of those activities. And the impressive part is that 92% of these farmers attend and participate in these activities. This means that if we bring more farmers on board and we involve farmers in our forums like these, then that means that we'll have a number of them knowing about our research technologies to ensure that we get more participation and food security is ensured. In terms of the services, because the services multi-actors provide to farmers will determine whether the farmers are able to adopt a technology. Farmers require you to give incentives and inputs for them to participate in your research. So input supply, financial support, and extension services were the main aim here. And you find that the extension services were the leading. We had the trainings that is under extension. Market information is very key also, because a farmer cannot do any research without knowing the benefits at the end. And then input supply was also key. But the least was the financial support. So if we come together as stakeholders, we'll be able to bring farmers on board to be able to provide finance as a joint so that the technologies can be adopted. So in conclusion, services by multi-actors communities may determine the farmer's level of adoption of a technology. If you provide services, the farmer will be willing to adopt your market engagement can also be critical for disseminating the push-pull technology. We bring all the organizations together who are supporting the push-pull. Then they will have a shared idea, co-design and construct on how they can share these informations. The last one is most dissemination of push-pull technologies research, can be attributed to research centers, the ISIPEs and universities, because they are able to do demonstrations, call for field day, call for exhibitions where farmers attend and learn more. So recommendation, we should be able to have a structured multi-actor engagement. This one will bring a transdisciplinarity where all disciplines are together. We share our ideas and we are able to get a long-lasting solution in terms of agricultural technology. And last, additional lead farmers should be able to be engaged. Under the upscale, we have lead farmers, but we need to engage more, and this can't be done by alone. We need other organizations to bring lead farmers so that they are able to know. So those are some of the references that I worked on. So last, I want to appreciate Maseno University upscale project and also the EU upscale Horizon 2020 for sponsoring my research. Thank you.
Okay, let's appreciate her. Thank you. Thank you also for keeping time. You've stopped at after exactly 10 minutes. Thank you so much for that. Like we had indicated, we'd allow for 1 or 2 questions or clarifications from the presenter before we move to the next presenter, who is supposed to be, like I said, Cosmas Kiprono. And I hope the presentation is ready. Any clarifications, any questions? Yes, I'll start with Mera.
Okay, thank you very much for that presentation, Esther. You mentioned that 92% of farmers participate in the multi-stakeholder activities and 77% are aware. I don't know, awareness and participation. I'm thinking if you're aware, okay, 77 are aware, but I'm thinking that the percent maybe should be around the same. And then the other question is, so how much percent, what is the percentage of farmers who have adopted this technology? And based on the title, is that the role of multi-actor communities of practice in dissemination. So I was expecting to see maybe the percentage of multi-actor communities who are working together, and maybe what are the challenges probably that are there for them not to work together, or what are the achievements in working together. Thank you.
I think we can take the second one. And I think those were the only raised hands.
Thank you very much. My name is Dr. Ngotho. I work with the Animal Sciences Department. I come in from the livestock angle because I think many farmers are not just doing crops. They are also doing other activities with respect to livestock, and therefore they are mixed kind of. Was there any instances where you had interaction, and whether or not the adaptability that you saw with respect to crops, whether that can be advanced to the other sectors of the farmers' involvement, particularly with respect to livestock? And I'm talking about the need for us to address the issue of antimicrobial resistance. Of course, that's another topic altogether, but my question is, how willing are the farmers able to deal with not just what you are advancing for the maize and crops, but for other aspects of their farming experiences? Thank you.
Okay, thank you. I'll begin with the first question. In terms of the adoption, under the results, I gave the 77%. That one was awareness of push-pull technology, but not the awareness of multi-actor. So the 77% was awareness of push-pull. And then the awareness of multi-actors was 48% from the sample that I worked with. So you asked about the 77. That one was for the push-pull, those who are aware of the push-pull. Remember, in my paper, we have those who adopted, then we have those who adopted but disadopted later, and then we have those that had never heard about push-pull technology. So in terms of the awareness, because I was focusing on awareness, because the title is focusing on disseminating the push-pull through the multi-actors. So that is why I gave the 77% in terms of awareness. So that means that the 23 that are remaining still needs that the multi-actors can engage together for the adoption to take place. So, and in terms of the livestock, through the farmers that we are moving around, remember we have Desmodium in the farms and Bracharia, which have importance in terms of the nutrition. So that is one area that if you will tell a farmer that if you adopt this technology, we have Desmodium and these are the benefits of Desmodium in terms of milk production that they are able to get, you'll find that a farmer had more interest on adopting it, because from the research, most farmers grow Desmodium or Bracharia just for feeding of the livestock, not knowing that they can grow them in an intercrop to control the pest in terms of the crops they grow, and at the same time, the animals to get feed for their animals.
Okay, thank you. Maybe one last one. I know time is up.
Yes.
I just out of curiosity, out of the farmers who had adopted and who knew and all this, were there any significant differences in their productivity or in their production? Did you pick that, or is that part of another study?
Okay, there was a difference in terms of the production of the adopters and non-adopters. In terms of kgs, at least we realized that in productivity, the other farmers who are doing the push-pull were able to get 42 kilograms higher than their counterparts. Remember, in push-pull, they were using small, if you compare them with the non-adopters, you find that they have large parcels of land, but those adopters are still operating in small parcels of land. So from that benefit, the 42 kgs, if they are engaged more, then they'll be able to expand their farms.
So much. Let's appreciate her. In the interest of time now, I want to invite Cosmas. Cosmas has co-published this work with George Odhiambo, Barun Ogindo, Frederick Aila, and Benjamin Obok. I hope I've pronounced the names correctly.
It is Professor Arun Ogindo, not Barun. It was supposed to be Arun.
Arun, okay. That's what is written, and apologies for that.
Thank you.
Okay, welcome, and the floor is yours. 10 minutes.
Good morning, everyone.
As he prepares, the title of his presentation is Upscaling Multicropping System of Maize Desmodium Species with Vegetables as a Sustainable Development Strategy in Agriculture.
These are peer review paper in collaboration with Professor George Odhiambo, Professor Ogindo, Dr. Aila, and Ombok, all from Maseno University. So farmers have been focusing on strategies to increase food production. This is due to increase in the world. This is due to increase in population globally, according to the United Nations. Multi-cropping system as a viable means to increase agricultural production and an approach to integrate more crops efficiently and offer several benefits, which includes the better environmental utilization, the soil stability, and soil conservation. Now, these available resources in multi-cropping system are used more effectively, there's minimize waste and improve the overall productivity. Now, maize desmodium cropping system has been instrumental in increasing maize yield. Intercropping maize with vegetables like tomatoes, onions, kale, spinach, cowpea is so much productive too. Now, this combination allows more efficient use of space, resources, while also providing a diverse diet for local communities. Now, this is the maize desmodium, and this is where we have intercrop or upscale the maize desmodium with vegetables. Overview of multi-cropping system. In multi-cropping system, we have land utilization, where we integrate more than one crop. There's nutritional diversity. For example, this photo, which was taken from Maseno University farm, which is an upscale project, we have maize, which is one of the carbohydrate source, and we have vegetables, so a good source of vitamins. There is improvement in crop yield or crop productivity. As we review this paper, most of the intercropping system or papers that people have done their research, in general, there was improvement in yields in maize and also in kales, other crops that was intercrop. IPM mechanism, desmodium, which has been practiced mostly in a push-pull technology system, has shown a control, a significant control in striga weed and other pest management. Features of multi-cropping system. In multi-cropping system, we can see competition, or we can just, when we analyze, there's some competition where these crops compete for same resources such as sunlight, water and nutrients, and also space. This land equivalent ratio, where we quantify the best between the sole crop and the intercrop system. This microclimate, when we intercrop this system, for example, as we see that photo, where we have the kale and we have the maize, different heights. So there is creates a microclimate within that system. This plant population. This when in a multi-cropping system, we have plant population. There is increase in plant species of different methodology. Now, this paper was synthesized, was a systematic review that on multi-cropping system, diversification, climate change, and for sustainable agriculture. By analyzing these studies using a Google Scholar as a searching engine, we included 7 systematic reviews, most of which were published in the last 15 years. These reviews covered various climate change, resilient farming systems, crop productivity, multi-cropping, and sustainable agriculture. The results from the peer review, we found that this multi-cropping system, there was an increase in yield, there was an improvement in soil health, crop diversification, there was repel pest, or one of the control mechanism. There is reduce in environmental pollution, source of fodder, for example, desmodium. The source of income from the kales after you have plucked, you can sell. Conservation of soil moisture. There's an improvement in soil fertility and nutritional diversification. In conclusion, this multi-cropping system represents a promising and sustainable development strategy in agriculture. It enhances resilience by buffering against environmental shocks by fostering the climate resilience agriculture. There was an improvement in soil health through nutrient cycling. This the leguminous desmodium has the ability to fix the atmospheric nitrogen. There's economic viability by diversifying income streams. Now, we recommend that researchers, policymakers, extension workers, and farmers should collaborate to collectively expand the adoption of this cropping system. This by organizing field days and establishing demo plots. We can successfully, as researchers, as policymakers, extension officers, and farmers, implement and scale this technology to benefit more farmers. I acknowledge Maseno University Upscale, which is an Horizon 2022, with other 17 partners for the funds for this project. Thank you.
Let's appreciate him. Thank you so much. Once again, thank you also for keeping time. You've used half of the time, so you've donated. You will donate that time to somebody else. Thank you. I want to invite any suggestions to him, any comments or any questions. Yes, there's one here.
Oh, okay, thank you. Thank you for a good presentation. I was just wondering whether in your review, you on vegetables, you found some vegetables that were benefiting more from the multi-cropping system than others. So I was wondering which one would they be, and probably why.
Okay, thank you. Maybe we can take another one. There's one more here. Thank you, Daktari, for agreeing to pass the microphone.
Thank you for the good presentation, Kiprono. My question is, maybe did you find what is the level of uptake from maybe the literature that you reviewed? And probably if you can expound on why did you use that specific species, the Desmodium species, for your case study?
Okay, thank you. Maybe.
Sorry, one last one. On your methodology, I didn't really get what criteria you used to select the studies that you used for the review.
And probably one final one. Now that you saw the benefits, were there any negatives reported? And if they were there, which ones were they of these multi-cropping systems?
Okay, thank you. I think I can start with lady at the other side about the adoption, I think, and the searching engine or the methodology which I use. So let me start with adoption. Now, this upscaling maize, desmodium with vegetables, this is a new system which has not been adopted so much, but compared to maize desmodium has been there. For example, push-pull technology is one of the maize desmodium multi-cropping system. So upscaling, this is now incorporating maize, incorporation of maize desmodium with vegetables. That's a system which is still new. It is being practiced or being under research. For example, the upscale project, which is under the EU 2020, is one of the for any project that is fostering this adoption of vegetables, maize, and desmodium. So it is a new, but yeah, we are now encouraging farmers, researchers like you, to do more research or at least foster this adoption to reach more farmers. The second thing is about methodology. Now, I could note there's a lot of studies which has been done on multi-cropping system, which I cannot look all of them at once, but I need to cover some range between. So now this was 15 years from 2020 to it was 13 years from 2010 to 2023. So those were some of the research papers as the reference that I've shown that has been done on multi-cropping system over that period of time. So I was able to collect some of the information and results that some of the people have found for those projects.
On choice, which of them did better? Which of these vegetables did better? Which one would you recommend for intercrop?
Now, this is a research which is undergoing, and I've just shown before that we can incorporate this maize desmodium with various vegetables. Number one was kales, which I shown one of the picture here, which is we are currently doing in Maseno University Farm. But also we can incorporate cowpea. There's some research which is undergoing, especially the ECP guys and the upscale project are doing the incorporation with the cowpeas. There are others which are doing with the onions, because this is a new system which is under.
So your answer to Daktari is that you are going to answer that next year as the study proceeds?
Yes, I will have the results. Then maybe next year when we have the same, I can have the.
And to my question on some of the shortcomings.
Yeah. Now, these are multi-cropping system. So, for example, as now, I'm looking for the effects of incorporation of this maize, desmodium with vegetables, and I'm looking for the nutrients, the competition aspect, which is the nutrients, the soil moisture, and the overall productivity. How will this intercropping system affect the overall productivity? So this is just a research, which, most of the past papers about the multi-cropping system of more than one crop, which is maize desmodium, it ensures that there's been a competition, number one, of space, there's competition of nutrients and also water. So these are new systems which you're incorporating more than 2 crops. So I'm looking for the competition. Then maybe the next time I came here for the same thing, I can just have the full.
Thank you so much. So I hope you will incorporate those extra points, those other areas that you had not looked at as you continue with the work. So thank you so much. Let's appreciate him. Next presenter is Dennis Mulupi, who is going to present on the affordable approaches to improve human and animal health and food security through regenerative agricultural practices. He's co-authored this work with Winnie Oliech, Cosmas Kiprono, Esther Ngonga, Frederick Kaila, Benjamin Bok, and George Odhiambo. Welcome.
Good morning all. My name is Dennis Kimoso Mlupi. I'm presenting a review paper on approaches to improve human and animal health and food security through agroecological practices. Introduction. We know that food insecurity has been an issue in Kenya, in sub-Saharan Africa, and in developing countries globally. And agriculture sector has experienced shortage in terms of food, where food demanded has always been greater than what is supplied. And we cannot address this issue of food insecurity without focusing on agricultural production, which is a key determinant. Intensive systems of production have been implemented as a solution. However, despite an increase in production, it is costly, it is causing resource degradation and initiating climate change. Therefore, we need more sustainable solutions or options where agroecological farming involving conservation agriculture and agroforestry have been adopted by many farmers. This is a typical farm practicing agroecological farming system where we have animal integration, we have composting, we have crop rotation, we have intercropping, and we also have feed production for the animals and food production for the people. We have agroforestation, and you remember our keynote speaker said that you need the right trees or the right trees at the right place and for the right purpose. Agroecology involves balance in the relationship between plants, animal, people, and the environment. And composting convert organic manure from the livestock, and this improve the soil fertility through the macronutrients required for crop production. We also have intercropping, crop rotation, and agroforestry as key practices in agroecological farming systems. And all these practices in the farm mitigate impact of climate change, and they also, by regulating the gases that are taken into the environment and have a positive impact on food production. That is the interrelationship between different practices in an agroecological farming system, where we have that is a PPT plot where we are integrating, where there is an integration of forage production and cereal crops, and this has different impact on the production, and it also produces the feeds for the animals. We have a crop intercropping. We also have agroforestation and composting. These are some of the practices of agroecological. The literature review was based on a few keywords, that is agroecological practices, human health, animal health, and food security. It focused on the current literature as well as relevant literature in the last 10 years. It also draws insight from the discussions at the East African Agroecological Conference, the perspective of multi-actor community participating in upscale project, the practical experience of the authors, and the main objective was to synthesize the existing literature on how agroecological practices can improve human and animal health and still attain food security. On the results and discussion, agroecological practices are necessary, and these practices offers a holistic approach to agriculture where it reduces the production cost, promote environmental sustainability, and diversified production. These agroecological practices also prioritizes organic farming methods that reduces over-reliance on external inputs and also enhance soil health and biodiversity. By integrating diverse crops and livestock, farmers can mitigate agricultural risk, increase income, and optimize resource use on a farm. These practices also fosters inclusivity. It encourages participation of women and youth in agriculture, as we know that women and youth are the youth will always like to engage where we have a higher income. Overall, agroecological farming contributes to sustainable food production, livelihood, and also climate resilience. Those are just a few of the reviewed papers. How does this now improve human health and animals? We know that in agroecological farming practices, we focus a lot on producing chemical-free food. We also focus on soil and biodiversity conservation, diet diversification, and once you diversify your diet, you know how important and nutritious the consumption system of the people will be. The quality feeds will also impact on dairy production and livestock production. And the product certification, we have been talking of research, innovative product development. And how will you know that, how will you differentiate this product on market, that these products have been produced organically, unless we have product certification and eco-labeling? So product eco-labeling and product certification have advantages that, one, the product differentiation will take place. And once you have product differentiation on market, you are sure of which kind of product you are consuming. If it is organically produced, you are sure of that. The second one, it will improve the market access and even the premium prices for these organically produced products will benefit the adopters of these practices. Consumer awareness and demand. Once we eco-label and certify these products, consumers will be aware and will also raise the demand. Access to government incentives, peer-to-peer learning and collaboration, research and development funding, continuous improvement and accountability, global recognition, and trade opportunities. In conclusion, to promote human and animal health and attain food security through agroecological practices, product certification and eco-labeling are very important, and this will increase the consumption of free chemical food. Recommendation, certification and eco-labeling of product from agroecological farming systems, including PPT farming systems and regenerative agriculture, among other systems, should be implemented. Those are some of the references. I acknowledge Maseno University and the 17 upscale partners and the EU Horizon 2020 for funding this project. Thank you.
Okay, thank you. Let's appreciate him. Thank you. Maybe for the clarity for everyone, we are having 10 minutes presentation and 5 minutes question time. So this is question time. If you have any question for the presenter, kindly within the next 5 minutes. We'll start with the chair of the council. If there is any other question.
Thank you very much. That's very good presentation. This piece of work, from where I sit, would benefit from a review within to show that the high agriculture input, this level of production levels, yeah, and the following baggages, you know, more disease, more blah, 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 more blah, blah, blah. But ours gives this kind of production, benefits and human health. But even as you make the claim of human and animal health, there must be a paper that actually has addressed health. There must also be a paper which you reference that has addressed this in both animals and plant and humans. Because in science, when you say that because you are eating a diverse menu, that's not good enough. There must be some, because this support your case. Eco-labeling has its own challenges. This paper would have been more useful if you said those challenges. For example, if you wanted to claim that this food has been organically produced, you will have to get auditors. They're based here. They are normally from the West. And they will go through your production line from land preparation to harvesting to make sure that you don't have inorganic fertilizer, to make sure that you don't have pesticides, to make sure that the organic manure that you use is not from cows that are sprayed against ticks, from cows that have antibiotics when they get sick, goats that have received this and that treatment. You get permission or authority or a certification to claim eco-labeling. If you don't include that in this paper, then the person reading this paper will be faced with a lopsided information. And people can run adopting this without getting the full story. Okay? That is my comment on this.
The opportunity to respond to that which you need to respond to and make notes of that which you need to include in your work as you move on.
Okay, thank you, Prof. I will consider looking at the comparative analysis on what is produced organically, the benefits, and what is conventionally produced, and incorporate it in the paper. I'll look at that. And look at the challenges again. Okay.
The reason productivity is important is because of food security. Yeah, and I'm not in any way saying pesticides are good. No, I am saying that your alternative must be competitive. It must replace the other system. If it can't replace because you do not get as high yields, then you are stuck with the other system. And you might not produce a strong enough case to sway the policy thinking. Because unless policy support what you are saying, countries cannot do what you are saying. And as a Kenyan, if you gave me this and asked me to make a decision, I will ask you for data from the conventional.
Okay.
Okay?
Yes.
Yeah. All right.
Yeah.
Are you through?
Yes.
Okay. Thank you. Thank you so much. Let's appreciate him. So our next presenter is Gedefaye Achamo. Are you around? Gedefaye? If he's not around, then we'll go to Lidambiza Muhandale. Oh, he's around. So Lidambiza Muhandale is presenting on smallholder farmers' willingness to pay for plant health management technologies. He's co-authored with, together with Josiah Ateka, Robert Beche, Luke Oyugi, and Lucy Kananu. Kindly also remember what we've agreed. If you are presenter and you are here, kindly organize with the media team before your name is called. After Lidabiza, we'll expect to hear from Githui, followed by Sylvia, in that order. So kindly, if you are here, kindly liaise with the media team to make sure that we don't take a lot of time transitioning from one presenter to the next. Thank you.
Good morning, everyone. My name is Lidambiza Muhandale, and as he said, I'll be presenting a paper on smallholder farmers' willingness to pay for plant health management technologies. The paper is co-authored by Robert Mbeche, Dr. Ateka, Professor Yugi, and Dr. Kananu as well. So potato as a crop ranks fourth in terms of its importance globally, but in Kenya, it comes in second after maize. But now, potato productivity and production has been on the decline, which is attributed to rise in potato diseases and pests. And as you can see, past studies have published that the productivity in Kenya for potatoes stands at averagely 7.7 tons per hectare, and some farmers it's down even to 3 tons per hectare. Now, PCN, which is highly prevalent, can cause losses of up to 80% or even total crop failure if not managed, if not well managed. As you can see in the next slide, we have the trends. You can see initially the productivity was high, but with the years progressing, the production has increased. But now the productivity per unit area is what remains a big challenge. Now, the two technologies at hand to handle the issue of PCN, the study measured on what we call wrap and plant technology, which is a banana paper matrix, and we have the PCN resistant varieties, such as the Cara and Maris Piper. There's evidence that these two technologies can increase productivity and help reduce the negative impact of PCN on potato production. But what's not clear yet is the level of uptake and the willingness of the farmers to pay for the two technologies. Now, the objectives guiding the study were to determine the factors influencing the adoption of PCN management technologies amongst the farmers, and to evaluate their farmers' willingness to pay for the technologies in Nyandarua County. The study was purposely done in Nyandarua County as it is the leading producer of potato crop in Kenya, and also it has the highest prevalence of potato PCN cysts. You can see Kinangop, or Kipipiri, Ndaragwa, or Jorok, that's how it's distributed. So we sampled 389 households that are farming potatoes, and also through FGDs and KIIs we were informed more about how the potato status is. We used the probit to analyze the determinants of adoption, and the other probit to help us establish the level of willingness to pay for the farmers. Then these are the results that the study found. As you can see, the level of education and group membership, productivity, and potato land size, there were significant differences across the areas studied, and the results are in line with the, for example, the age of the household size, household head, you have the household size, they're in line with the Census 2019 results. Then as you can see, the productivity of potato averagely is high in Kinangop sub-county compared to the other two sub-counties, and potato land size is averagely at around 0.94 acres. The productivity, which is key here, averages around 50 kg bags per acre. Then when you look at the disease awareness, you can see that for bacterial wilt, around an average of about 80% of the farmers are aware of the disease, and early blight and late blight. Unlike PCN, the level of awareness across the three sub-counties was quite low. And now that explains why the damage caused by PCN is quite high, because the farmers are not quite aware of the disease and its impact so far and its management. Now, when you look at the determinants of adoption for PCN resistant varieties, some factors were positively significant and others had a significant negative effect. For example, the age of the household head, it had a significant negative effect because the older farmers were more risk averse. They weren't willing to take the risk of adopting a new technology, unlike the younger farmers in the area. The potato plot size had a positive significant effect, and those having larger plots were willing to adopt technology so that they could reduce their level of losses. Now, when you look at the seed type, it had a negative significant effect. Reason being, most farmers who are using the alternative seed types, those ones that weren't using certified seed, they were quite not really willing to try out the new technology because of the costs and other factors maybe. And now membership to farmer group, it has a positive significant effect since those farmers who are in registered groups received more trainings and shared more information across themselves about potato diseases and its management. Now, the last bit on willingness to pay for the PCN management technologies. We use the double-bounded contingent evaluation method to come up with the bids and see to what level the farmers are willing to pay for the two technologies. So the bid amount is the price above the average market price for a 50 kg potato seed bag. So for instance, we give the farmer an initial bid. If they accept, we give them a higher bid. If they reject the initial bid, we then go to a lower bid. So as you can see, for the wrap and plant technology, the average willingness to pay level was at 793 Kenyan shillings. And for PCN resistant varieties, the average was 756 Kenyan shillings. As you can see, in Kinangop County for the two technologies, the farmers were willing to pay higher. This attributed to Kinangop being the leading sub-county in the county for production and also for PCN-related losses. Now, keep having in mind seed rate per acre and the potential yield increase. Now, the two technologies would help the farmer to reduce their losses for up to 60%. If they adopt the technology from whatever the results show here, the cost of adoption will be lower than the income that they would get, and those adopters would have higher income than the non-adopters. So, in conclusion, there is higher level of awareness of other potato diseases other than PCN. Now, the adoption of the two technologies is mainly anchored on farmer training and awareness of the diseases and other potato production issues. Then we have generally negative attitudes towards wrap and plant because of its nature on how to use it. It's quite labor intensive in a way for adoption. Then also for the recommendations, they're quite direct recommendation for this study was for the maybe extension officers to disseminate information to farmers in a more accurate and timely manner on how to control the pests and diseases using the good agricultural practices, and also maybe help in certification programs where farmers, where there would be where certification programs for seed potato to ensure that it's PCN free at the time of planting, and also the wrap and plant technology to help make it less laborious and for those farmers that would adopt it, because it involves wrapping a potato in the PCN paper before planting it. Then I would like to, I acknowledge JICA for sponsoring the project under the JICA project phase 2. Thank you.
Okay, thank you. Let's appreciate him. Okay, thank you so much. Once again, we have an opportunity to make suggestions to him, ask him questions or clarifications. Chair, you go first. No, you are the first one to raise the hand. Yes. Any other, you can raise up your hand. Yes.
Yeah, this is good work, I must admit. But Africans eat food for taste. Did you know that? That's why we eat nyama choma, although we know it's killing us. Yeah, but because it's very tasty, we can't resist. And we eat with the mouth, the nose. So how food looks, how it tastes, and how it smells. Not bad smell, but aroma. Yeah. So it would have been important if you wanted to market this. It would have been important to mention quite a bit about the organoleptic traits of the BCN tolerant varieties. Yeah, and now, if a variety is tolerant, if a potato variety is tolerant to cyst nematode, but it doesn't appeal to the market, nobody will adopt that. So as we do some of this work, let's be critical and see whether we have everything in the package to influence what we want. For example, the table potatoes are different from chips and crisp potatoes. Did we all know that? Yeah. The chip crisp potatoes must be very high dry matter so that they are crispy. The table potatoes can afford to be a little lower in water, in dry matter content, can still. So, in this work also, I think it would have been nicer to say, these two varieties, are they good for cooking or for frying? In other words, are they table potatoes or are they potatoes for crisps and chips? If they are good crisps and chips, then you can attract markets like Kentucky chicken. If you attract those markets, then the value of that potato will be so high that the farmer will afford to get the tolerant variety. Are you getting me, young man? The argument, the thinking that should go into this kind of work. Yeah? I am sure you wanted to first finish your degree and then worry about that later. But you do your degree, try to solve some practical problem. Yeah. So maybe a response, but that is very good work, but it could have benefited from a wider thing. Yeah.
Yeah, thank you. I think I concur with the chair that is quite very good work. I was just looking at your conclusions and recommendations about the role of different people. For example, when it comes to this new technology, PCN, and I was wondering, before you went to the field, did any farmer know about PCN? Now, I think that brings up the issue that the issues that we have here, especially in this part of the country, when you say that when you talk about the role of extension officers and what they do, the thing I would also ask you, is there anything like extension services in Nyandarua? So when you talk about increasing the role of extension services, I think the first question is to ask, is there any activity that happens when it comes to extension officers? And if not, how can farmers be helped to take up new technologies as we are? For example, the accessibility of the certified seedlings. I don't think it's when you ask the farmer whether about the willingness to take up the technology and relate that to accessibility of certified seedlings. As the chair of the council says, if the farmer knew that a seed, the certified seed would give them more profit, I think they would go for it. But it's not their problem. It's not accessible. So I think basically we don't have extension services, and that's the problem, where the problem is. I don't know how you'd respond to that. Thank you.
Thank you. I think we'll only manage to take those two. You can kindly make a comment or where you need to note, you kindly note.
Okay.
Yeah. Oh, sorry.
Yes.
Thank you for the presentation. Mine is just a comment. You were talking about PCN, but in your title you mentioned plant health management technologies. So it looks like it's in all plants, but immediately from the beginning you talked of PCN. So maybe you can consider adjusting the title to fit PCN.
Okay. Thank you all for the comments and questions. So let me address Prof's issue at first. So here are the two technologies at hand. One is PCN resistant varieties, and second is wrap-and plant technology. Now, the wrap-and plant technology is your potato, the one that you have, whichever variety it is, you wrap it in that banana paper, just as shown it's there. So you'll still produce the same shangi you're producing, the same unica that you're producing. So for that, you'll still have the same properties. But now for the PCN resistant varieties, I'll look more into that. Okay, thank you. Then to the second one, on the level of awareness about PCN. Now the level of awareness about PCN, I showed in a slide here, it stood up at an average of 31% across the 3 sub-counties, which is quite low when you compare it with the other diseases. The other diseases, an average of 75 to 80%. Then now the role of extension officers. From the study, those members, the potato farming households that belonged to a registered farming group were the ones who are more aware of PCN, and when we look at productivity, they had a higher productivity. They were benefiting more from the extension services they receive through the groups. Yes, there are extension officers on the ground, some from IFDC, some of IITA, that go to the ground and educate farmers about potato diseases and its management, but through farmer groups. So it's only those farmers that are in registered farmer groups that would directly benefit first, maybe before the information is diffused to the other farmers around them. Thank you.
For the very good presentation. Let's appreciate him. Now, we want to do a little bit of housekeeping to help us manage. You are aware we have a challenge with time. So we want to first confirm how many of our presenters are around. I know earlier on we missed, what was his name? We missed Gedefire. Is he around? So that we can tick them off. Githui, are you around? So Githui is also not around. Sylvia Buleti, you are here. For the purposes, Rahab Mbai, Rhoda Mbai, are you here? Okay, Rhoda Mbai is here. And then we have Elisheba Imbaya, you're here. Garrison Kiprotich, you're here. Damus Wanjiko, not here. Collins Kaisha is here. Then we have Ireri DM, not here. Alaric Brown. Then we have Zacchaeus Kijita. Is it Kajita? Zacchaeus. Grace Jogona. Oh, she's around, eh? Evelyn Chepngetich. You're here. Thank you. And Maureen Akinyi. You're here. And finally, Chepngetich Naomi. You're here. She's not here. So thank you. Yes? Yes. Okay. Then by the time we finish, we'll sort that. So you prepare to be the last one for now. So our next presenter is, as per the program, should be Sylvia. And after Sylvia, I'll be stepping down, and my colleague, Dr. Indeche, will be taking over. After some time, Dr. Ngodo will take over to chair the session. So Sylvia is presenting on performance of intensified push-pull technology in smallholder systems in Western Kenya.
Thank you. My name is Sylvia Buleti, as has been mentioned, and welcome to my presentation. Sorry, today you have to hear a lot about push-pull, but not worry. This work we have co-authored with Dr. Kuya, Dr. Moses Gishua, and Dr. Samuel Were. I'll not belabor to explain what push-pull is. We have heard about it. I will start with what has been the main challenge and what led us to doing this work. We had focus group discussions with farmers just to understand from them, and key informant interviews to know what is it that could be done to this technology to make it more acceptable, and also to find out some of the needs that they had. And the critical needs that the farmers in Western Kenya mentioned were fodder, firewood, and diversified food. As we understand, push-pull is majorly maize intercropped with desmodium, and then you have bracket on the border. So for the longest time, it has been used for the production of cereals, and the farmers felt that there is need to introduce another crop that can be able to meet the needs that they have. And we understand that the land is not increasing in Kenya, but the population keeps increasing. Therefore, we have to think of ways that we can be able to produce all that we need in the same portion of land. That is where crop diversification comes from. So this work was done to determine the effectiveness of push-pull system that has been integrated with pigeon pea. This is because traditionally pigeon pea is produced in the eastern part of Kenya, and so in western is more like a quote unquote a new crop, and push-pull having been there for this time, we needed to know when we introduce another crop, how does it perform? So for this particular presentation, I'll majorly present on basically the growth and also a bit of productivity, but for the soil fertility, we are yet to work on it, so we'll present later. The work has been done in Kisumu, Siaya, and Vihiga counties, where push-pull has majorly been practiced. And I had 4 treatments where I had maize and desmodium, that's the conventional push-pull, and then I had maize intercropped with pigeon pea, and then I had maize that has been intercropped with both pigeon pea and desmodium, and a maize monocrop. The work that I'm presenting is majorly for 2 seasons. I have done it for 4 seasons, but the first and second season has previously been presented elsewhere. And so that is why you see on the planting and data collection calendar, we had data collection in different times. The season 3 represents the short range season of 2022, and season 4 represents the long range season of 2023. The data that was collected was for the growth parameters, majorly for the maize and the pigeon pea. That's basically the height, the length and the width. And then I also looked at the cob weight and stover weight and grain weight, which are simulations from the cobs. The photo shows us how a typical push-pull looks like once you have already established it. So we only established in the first season, but then for the consecutive seasons, we were just using the already established plots. Then these were the procedures up to the drying of the components. On to the results for the growth parameters, we realized that integrating pigeon pea in push-pull did not affect the leaf length. And then for when we intercropped maize and pigeon pea, we realized that the maize height was kind of reduced in one of the seasons, but this was not the case for season 3 and the previous seasons. Season 4 was a unique season where it was supposed to be a long-range season, but the rains did not come at the time that it was anticipated, and then all of a sudden there was this heavy rainfall, so it really, there was differences. And then since push-pull is also applied in the management of striga, we also looked at the effects of the intensification on the striga number, where we noticed that the striga number was actually reduced when we integrated the pigeon pea within the system, which was interesting to note. It was also interesting to notice that in season 4, the striga number was higher for the conventional push-pull technology compared to the other treatments, which has not been the case, but there's a paper that has presented similar results where the striga number is lower in a push-pull crop. And then we noticed that when we have integration, where there is desmodium, the farmers have additional benefits. Generally, the striga number across all the seasons was highest in the maize monocrop, and with the rest, it was not significantly different. And then across the counties, Kisumu had the highest striga number compared to Siaya and Vihiga. Then when it comes to the grain yield, we noticed that intensification of push-pull with pigeon pea did not jeopardize the stover yield, and in some cases the grain yield. What this means is that it is a positive result for us, because when you introduce pigeon pea, you're reducing more like the plant density because of the kind of spacing that goes into consideration. But then with this, you notice that in the third season, the grain yield was enhanced. Something else that I also need to mention is that in the 4 seasons, we only planted pigeon pea in 2 of the seasons. That is season 1 and season 3. For the pigeon pea productivity, you can see that we have other benefits like the root collar diameter. We have benefits of twigs, benefits of leaves. That is where we have pigeon pea, something which is not there when you only have the conventional push-pull or when you have the maize monocrop. It was also interesting to notice that when you have pigeon pea introduced in the push-pull, the productivity of pigeon pea was more enhanced compared to just maize and the pigeon pea itself. Across counties, Siaya, when it comes to pigeon pea root weight, performed better than the other two. And of course, the MDP, which is the maize, which is the push-pull integrated with pigeon pea, also performed better. We noticed that when you have pigeon pea introduced into the system, there's a chance of diversification where, yes, the yield is maintained, or in some instances it is it may be reduced, but you have additional benefits, which is we're talking about fodder, we're talking about firewood, we are talking about sources of material for organic manure. And then there is also potential for further production, because even this pigeon pea, as we had a detailed discussion with the farmers, they informed us that now they could use the crop products for making manure. So in conclusion, I would say that push-pull diversification has this potential for upscaling the benefits of push-pull in East Africa, so that farmers have alternative options. They have the fodder, they have the firewood, they have the food from the pods, and also they can be, this photo shows manure that has actually been made from a mixture of the pigeon pea, the desmodium, and cow dung, and other sources of poultry manure. So I would recommend this to the farmers as a way of diversification of the system, because as we know that the maize productivity is constantly decreasing and climate change is happening, so we can't continue saying that pigeon pea is just a crop for the East African, the eastern part of Kenya only. We need it across the other parts of the country because it has this potential. And also the fact that we noticed that the striga weed density was actually lower in some of the farms where, some of the treatments where we had the pigeon pea integrated with the maize. It could be an alternative, because again, we have the problem of labor intensity when it comes to working on desmodium. So this could be a possible alternative. Thank you for listening.
For keeping time, we very quickly we'll make suggestions to her, ask any questions that you have, and we try to limit that within the next 5 minutes so that you can move on to the next presenter. Any questions from the audience? Any suggestions?
Data to recommend for East Africa. You have data in Western Kenya, that's it. But you said East Africa.
I was saying East Africa. Okay, I don't have the data yet.
You know what that would say? You have several sites in Burundi, in Rwanda, in Tanzania, in Ethiopia, in Kenya. Only 10 can say.
Yeah. Maybe it's something we can consider, because Upscale is working around East Africa.
But this
data is just for Kenya only, Western Kenya actually. Thank you.
Okay, thank you so much. If there is no other feedback, we want to appreciate her as she sits down. Thank you. My colleague, Dr. Anna Indeche, will proceed from here.
So thank you very much for your patience, and to all the presenters who've gone before me. My name is Dr. Anna Indeche. I'm a lecturer in the Department of Horticulture and Food Security, and I'll be moderating this second part of the presentations. So without taking much time, we will go on to the next presenter, who is Rhoda Mbai. She's looking at assessing food loss and waste in the potato value chain in Kenya. She has co-authored this paper with Josiah Ateka, Robert Mbeche, Marceline Maina, and Collins Kaisha. Welcome, Rhoda.
I believe that it's still morning. Good morning, everyone. I'm Rhoda Wamwene, and as they get my presentation ready, maybe I can talk or have a quick setup on what they're doing. I'll be presenting on assessment of post-harvest losses, specifically on the potato value chain, and we are continuing the discussion from where our previous presenter, Batuan Alvin Muandale, had reached. And the paper is co-authored by Dr. Josiah, Dr. Mbeche, Collins Kaisha, and Marceline. Yes, thank you. Okay. Yes, thank you. This will be the outline of the presentation, as you can see. And in the first thinking would be then the question that you might be having, it's what is food loss and waste? Food loss, it's basically the decline or decrease in quality and quantity of any food products at the production stage vis-a-vis food waste, which is again the decrease in quality and quality, but it is more on the other stages of the value chain apart from production. That is at the retail stage, food services, and the consumption level. In this study, we based it on the argument that yes, in Africa or in sub-Saharan Africa, ideally what we are facing a challenge of food security, that very much food insecure, and this one of the contributing factors, it's what we are calling food loss and food waste. And that we are saying that over 20% of the food that is produced is wasted in sub-Saharan Africa. Consequently, over 1.157 million people are facing hunger. Out of these losses, the fresh fruits and vegetables, they are the ones which are the substantial losses at 45%. That you can imagine, out of what we produce in terms of fruits and vegetables, 45% of that goes into waste. And then what could be the factors which mainly trigger the fresh vegetables value chains to have much losses? It is what we are saying that one, it's the distinctive characteristics of the fruits and vegetables, and the other one, it's maybe the issue with the infrastructure. So it's outside exogenous factors outside the value chain itself. And we are saying, despite having these high food losses, the governments and other non-government bodies, they have initiated programs such as the warehousing and other infrastructures to develop infrastructures in order to handle food waste and food loss. Despite that, we are saying that despite these efforts being in place, we are still having very high losses on the same. If you look into the literature, again, it's that the case that a lot of studies have focused their attention on other value chains like cereals, which are considerably have a longer shelf life. They can be stored for long. Contrarily, the fresh value chains, they have a very limited literature which is available. So, to address that gap, this study seeks to assess the magnitude of food loss along the potato value chain, and again to identify what are the causes of this food loss, what are the drivers of food loss. To be able to address the problem that we identified, we have followed this conceptualization of the stages of food loss. This was majorly through literature, and we identified those 5 key stages, which is pre-harvesting and harvesting stage, sorting and grading, transport, storage, distribution, and processing. In our study, we followed, we did it at Nyandarua County, Nairobi, Nakuru, and Meru. In Nyandarua County, we did it at the first phase. The first phase included the household level or the household survey, whereby we were focusing on the producers. Then at the later stages, we looked at the other actors along the supply chain. These actors included the aggregators, wholesalers, retailers, transporters, and food service institutions. The activities that we did, this is following the framework which was proposed by the FAO in 2011, that we did a screening of the existing literature, then proceeded to the fieldwork, whereby we did key informants interviews, focus group discussions, and the household interviews. Consequently, we did sampling. Under sampling, what we were doing is what we call load tracking and physical sampling. Out of what you produce, or if a farmer grows 0.5 an acre, what is the potential of the quantity that they produce, and probably how much is lost from that, so that we can compare that with the data that you're going to get from the other farmers. Then the last stage, it's the synthesis, which is the presentation of the findings and the report writing. The analytical process, we majorly used descriptive statistics to analyze the 2 objectives, and again we used K-Wallis tests majorly to give an overview of the attributes of the farmers and the other actors that we were dealing with. On an overview, in terms of descriptive characteristics, these are at the farm household level. We were able to establish some key distinctive attributes across the farmers in the 3 sub-counties that we were focusing on. And of this, land size accessed, number of seasons, food expenditure and non-food expenditure, and also distance to the markets, productivity, they were different across the regions. Then this is of interest to us, was the assessment of the magnitude of losses at the household level or at the farming stage or production stage. We can see that the harvesting stage contributed up to around 15.5%, and it was significant across it was significantly different across the 3 sub-counties, whereby the sub-county that you are calling the Oljororok, or the Oljororok sub-county, had the highest level of losses at the harvesting stage and also at the storage stage. Those were our 2 critical points of loss in the value chain. If we consider now the other actors in the value chain, we were also able to identify some key differences between these actors in terms of age, gender, and education level. If you look at age of interest, it was that the wholesalers and retailers, they were a little bit older, and we could identify this or explain this with the issue of capital requirements, that as an aggregator or a wholesaler to operate, you might need quite a large amount of capital to operate, and again resources and the issue of security. If you need finances to do any venture, they also play part. Then the other key important issue that we found along these actors, it was the gender roles across the value chain. That some, if you look at the issue of the aggregators and transporters, it was male dominated. Wholesaling, it was partially, it was equal, 50-50. Then if you look at the last one, the retail and foods FSI, what you're calling the food service institutes, it is the case that it was more female dominated. Then the other one, in terms of education, the key interest was that the post-primary education was more with the food service producers or actors. Again, in terms of the losses, what we found, it was that this is the proportion. The left panel, or the panel on my far end, it represents the proportion of loss, while the one with the blue colors represents the quantities that these different actors handled in a week, the average. Then out of that average, we consequently measured how much of what you handled was lost. And we were able to identify that the transporters, wholesalers, and aggregators, they handled the highest volumes. And out of that, of interest is to acknowledge that transporters incurred no losses because of their role, the nature of their role. It's just being given a parcel and to deliver to the producer or to the person selling it. Then in terms of losses, the retailers and the food service institutes, they were the ones who were handling relatively low amounts of potatoes per week. But at the other end, they are the ones who are incurring the highest levels of loss. This majorly could be explained by two factors: that they sell in small quantities, so they end up storing these products at their stores for quite some longer period of times. And in terms of the causes of this loss, at the aggregator stage, it was rotten tubers. It was the most reported. Then wholesalers, it is diseased and rotten tubers, the same as retailers. Then at the food service institutes, it was food spoilage after cooking. It was the one which was reported the highest. Then we had also have prices variation, that as we go up the value chain, the prices tended to increase. Aggregators acquired the product at 28 shillings per kg, while the retailers acquired it at 39 shillings per kilogram. What then can we conclude from this? We can say that about 20% of the total produce at the farm level, it's lost, such that if we add the aggregate losses along the potato value chain, it can add up more to up to around a quarter of what we produce in the potato value chain is lost. The key causes, it was majorly cuts and bruises. I might have skipped that. At the production level, small and rotten tubers. And the drivers of this loss, cuts, it was the harvesting tools, whereby the farmers are using the forks, the jembes, and the forked jembes. Then the time of harvesting, the weather, poor packaging in nylon bags, extended bags, and poor storage were also among the drivers of the loss. Then we also conclude that the efforts to assess the magnitude of loss and waste are critical to informing the interventions that we take across the different critical points. Thereby, the study recommends that interventions to train farmers and other actors along the value chain on appropriate harvesting and handling techniques, which should be encouraged. Then the other part, it was improvement in storage infrastructure, especially what we are calling cold rooms and the diffuse light stores. This is because farmers are just basically using the native or the traditional storage mechanisms to store their products at the farm level. Yeah, that's the end. I would also like to acknowledge the JICA program, or the funding what funded the projects through their second phase of their projects. Thank you for listening.
Yes, let us give a hand clap. Let us clap for her. Thank you very much, Rhoda, for that very informative, presentation, especially on food loss, which is a major, contributor to food insecurity. Are there any questions from the floor? Thank you.
Thank you, Rhoda, for your presentation. Indeed, a good area we are looking at when you're looking at food loss. And when you consider it being second in Kenya only after maize, I come to think I just have a question when you're looking at food loss. I don't know where you'll categorize this that I'm looking at, but probably it will be under the food institutions. And I'm looking at possibility for you having tried to look at the preferences for consumption of the potato. Mainly what I'm looking at is the peeling. Because have you considered what loss or waste, I don't know if that will be a loss or a waste, we incur by peeling the potato instead of eating it as a jacket potato, and what are the preferences that we could look at if we did not peel the potato but we just washed it and consumed it as is. Thank you.
Thank you very much. Any other question?
Thank you. I like this presentation perhaps because it comes from the reach where I'm not very strange to. But I find it interesting that the transporters didn't incur any loss. Is that on account of how the selling and the transportation to the market is organized? Or is it simply that the farmer bore the loss if there was a breakdown on the way to the market? Thank you.
Yeah, that will be the last question from Dr. Ishua.
Yeah, thank you. That's a very nice presentation. I was just wondering if you considered also losses before you harvest, because I think farmers lose a lot of, for example, when it rains more than expected, most of the farmers, I'm sure, lose 100% of their produce. Or when they have planted and there is frost, they lose everything. And I think that is where the greatest loss is experienced. And I don't know how you can consider that part of the value chain, or why you missed out. Thank you.
Thank you for the questions. I would like to begin by responding to the one on wastes at the consumption level, especially through the peeling. What we did after identifying the critical or conceptualizing how we wish to do this work, we were not able to do the consumption or the waste at the household level in terms of consumption. But maybe to give a glimpse or an answer to that, I wish the slides were on. I would, but we had it could be represented by the food institutions, food service institutions. Yes, peeling is one of the most contributing factors at the processing and consumption levels, and it accounted, if we were to go back, it was accounting, we said that the retailers and the food service institutions, they are the ones who are handling small volumes, yet incurring the highest levels of losses. Yes, we didn't capture that at the consumption level, but maybe if we can borrow from what is happening at the food service institutions, yes, we can qualify or say that yes, peeling, it's a key contributor to losses. And what can we do about that? Maybe we need to go the traditional way, whereby they were just boiling and consuming them like that. Thank you for that insight. The other aspect on transporters, it is basically on how the arrangement of the value chain is. It's that transporters, their role, it's just to link this buyer or this actor, especially the wholesalers, to the retailers at the markets. So they don't take ownership of the package. If it's potatoes from Nyandarua, they want to take them to Marikiti markets or wherever they are taking them, they don't take ownership. So these losses are transferred to either the retailer, who later they have an arrangement whereby he's paid back. If the losses are quite enormous, they are reimbursed by the wholesalers or the people supplying to them. Yes. Then the last one, it's the losses at the pre-harvesting stage. Yes, we captured an element of that, and it was the quantities which are left in the field. If you come from the central, you'll hear something they call maetekia or something. What you didn't know existed, but it sprouts back, and yes, you can see some levels coming back. Yes, it accounted to around 6.03% on an average per farmer. Out of what they produced, 6.03 of that was lost. Yes. Thank you.
Thank you very much, Rhoda. Indeed, this can go on, and I know we would even want to ask the role of extension in all this, as had earlier been alluded to. However, we will not go into that, but we'll move on to the next presenter. That is Eli. Sorry, let me get the name correctly. I can't even. Thank you very much. Thank you. Elisheba Imbaya. She's going to present on performance of push-pull technology integrated with agroforestry in Western Kenya, work that is co-authored with Shem Kuya, Moses Gidhua, and Samuel Were. Karibu Elisheba.
So I'm going to present on the performance of push-pull technology integrated with agroforestry in Western Kenya. Okay, push-pull technology is a sustainable intensification pathway that has been used in the control of stem borers, fall armyworm, and striga weed. It has also been used in the improvement of soil fertility, crop yield, and cattle health and production. Whereas agroforestry is also another sustainable intensification pathway that improves crop yield, controls pests, improves soil health, regulates water and air, helps in the mitigation of climate change, provides products such as timber, wood, firewood, and fruits, and also helps in mitigation of microclimate, modification of microclimate. Recent studies conducted by Upscale, they identified agroforestry as one intensification pathway for push-pull. So therefore, the objective of this study was to assess the performance of push-pull technology integrated with agroforestry on pests, growth and productivity of maize in Western Kenya. So this study was conducted in Kisumu and Vihiga counties. The sites have a variation in rainfall and altitude, with low rainfall and altitude in Kisumu and high rainfall and altitude in Vihiga. The study was conducted on 10 farms, 5 farms in Vihiga and 5 farms in Kisumu. Okay, prior to this study, there was an activity that was conducted on characterization of the agroforestry system. So the activity identified Grevillea robusta as the most common tree within the cropland. So this study used Grevillea, Grevillea as the mature tree that was integrated with push-pull. The experimental design that was used in the study is the concentric zoning design. So in this design, the area under push-pull was divided into 3 zones, where we have zone A. So zone A is from the tree trunk to half of the crown, that is zone A, and then zone B was from the half radius of the crown to the edge of the crown. That was our zone B. And then our zone C was 2 meters away from the edge of the crown. And then we also had zone D, which was our control zone, which was 10 meters away from the tree or any other surrounding tree. So in this study, we have 4 treatments. We have zone A, zone B, zone C, and zone D. This study was conducted during the short rain season in September to December 2023. The maize variety that we used in the study was Decal 777. The spacing was 75 centimeters by 30 centimeters. One maize seed was planted per hole. And then to establish the push-pull, the desmodium was planted in between the rows of maize. And then after zone C, 1 meter from zone C, we established bracharia. Then top dressing was done with CAN at 6 weeks. The Grevillea trees that were used in the study were ranging between 5 to 30 years of age. So from the photograph there, we have the push-pull integrated with mature Grevillea tree, and then we have our maize monocrop, which was our zone D. Then the plant growth was monitored by determination of plant height, leaf length, and width. So 16 plants were randomly selected in northeast, south, and west directions from the tree. Height of the plant was measured from the base of the plant to the tip of the plant. And then the leaf length and width were measured from a fully expanded leaf of the 16 plants. The leaf length and width was used to determine the leaf area by multiplying with 0.75. Then we have the fall armyworm damage. So fall armyworm damage was determined non-destructively at 10 weeks. So here, all the plants in each zone were counted. And then the plants that were having the skeletonized leaves or heavily windowed holes were also counted in each zone. Then monitoring the productivity was done at a physiological maturity. So here the maize was harvested from 1 meter by 1 meter plots, which were demarcated in north, south, east, and west direction. So this means in every zone, in zone A, B, and C, each zone had a total of 4 subplots. Then the average fresh weight of the stover and cobs was taken from the plots, the 4 subplots in each zone. Then a fresh weight of 250 grams of stover was used to estimate the dry weight of the stover. Then the stover and the cobs were oven dried at 75 degrees Celsius. Okay, so the results on growth, the plants in Kisumu from the graph there, the plants in Kisumu were taller compared to the plants in Vihiga. And then generally in all the farms, the plants in zone D, which was our maize monocrop, had shorter plants. Then also there were no significant differences in the heights, in sites, and the zones. Okay, for the leaf area, low values of leaf area were also recorded in zone D. But the higher leaf area values were recorded in zone A. There were no significant differences sorry, there were significant differences in the leaf area in the zones. Okay, and then we have the results on the damage by the fall armyworm. So as you can see from the table there, most of the plants in zone B were affected by the fall armyworm damage, so it was 49.9%. And then there were no significant differences between zone A, B. There were no significant differences in zone A, B, and C in all the sites. Okay, in relation to the stover and grain yield, there were also no significant differences in the sites and zone in the stover and grain yield. Then also greater yield was observed in zone B and C compared to zone A and D. Okay, from this study, the lowest leaf area, plant height, and stover and grain yield was in zone D. This is because zone D was our maize monocrop, and the zone A, B, and C were the push-pull. So it indicates that the growth was higher in the push-pull plot compared to the maize monocrop. Then the maize plants that were growing near trees were taller compared to the plants away from the trees. This can be attributed to the increased organic carbon and nitrogen that is found near the trees. And then a higher proportion of plants was also damaged by the fall armyworm in zone D compared to the other zones. This was because zone D was our maize monocrop and the other zones were under the push-pull. So the desmodium in the push-pull helped the plants to control the fall armyworm damage. Okay, and then on the yield, there was higher stover and grain yield in zone B and C compared to zone A. This could be attributed to competition for nutrients, light, when the plants are grown near the trees. But as the plants move away from the trees, they tend to increase the yield. So these findings have also been found by studies that were conducted by Bayala and Sanao. And then in conclusion, intensifying push-pull with agroforestry has the potential of increasing crop productivity and reducing fall armyworm damage, particularly in zone B and C, hence encouraging food security in smallholder farmers in Western Kenya. Then also low production of maize in zone A will also be attributed to the shading effect of trees and competition for nutrients and water. So this study was conducted for only one season. So the future outlook, I also intend to assess the performance of push-pull integrated with agroforestry during the long rains and short rain season in 2024, where I'll assess the growth, productivity, and pests. Then also I intend to assess the effect of intensifying push-pull agroforestry on soil fertility. So on the aspect of soil fertility, I have already conducted soil sampling prior to the experiment. So I also intend to carry out another soil sampling and analysis after the experiment, and then I'll be able to compare the results and see if there is change. Okay, I acknowledge Upscale for funding the project, and thank you for listening.
Yeah, let's acknowledge that good presentation from Elisheba. Yeah, we were told that this afternoon we will hear more about push-pulling. And indeed, it seems like it's a very good technology for agricultural productivity. Any questions from the floor?
I I'm not asking a question or comment on the paper because I was not in, but there is a component I picked when I walked in and I need to share. Generally, if you are in very hot places and you have crops under shade from a tree that is compatible, the performance in that, under that environment will be very high. But that's not because of carbon, that's because of temperatures. Okay? Now, generally also, a lot of plants have chemicals we call allelochemicals. The concept is called allelopathy. This is a mechanism that plants fight competition. It's like they have herbicidal properties. Things like this plant that we use for timber, eucalyptus, and there's another one. Cypress. Cypress and eucalyptus will tend to kill because they emit allelochemicals. But there are other plants like Gilveria which can act, because one, they are legumes, and two, they are compatible with many other plants, and three, they don't produce chemicals. So a statement you made can be very risky to defend. After that background, are you with me?
Yeah.
Yeah? Saying that it was carbon, and you didn't even test the carbon, can be a very risky statement. You know, the beauty with science, if you support what you say with data, you are good. If you can't support it with data, support it with somebody's data. That's why we do literature review. Now, the reason we repeat trials, season 1, season 2, season 3, is to test reproducibility of data. If data is not reproducible, then that data should not even be published. In other words, if your second season trials don't agree with this, then you will need to do 3 other seasons to prove that your data is reproducible. I think because I'm addressing more of the younger people, I thought that I share that with you. Reproducible data is the one that we publish, because what we are saying is biologically correct. And how do we get into reproducibility? Because we can repeat the trial and get the same results. Okay? And as much as possible, if you have not Googled, don't assume. Because under eucalyptus, even if you pump tons of carbon, nothing will grow. Why? Because of allelochemicals.
Any other questions from the floor?
I'd want to ask, is there a potential of using indigenous trees as opposed to using, such like eucalyptus or gravelia?
Pardon, please?
Is there a potential of using indigenous trees, the ones that are locally found there, as opposed to using gravelia or eucalyptus or cypress for the agroforestry?
Okay.
I think you can respond to those.
Yeah, let me start with the I'm very grateful for your insight. Okay. And then in relation to the carbon, okay, there was a was conducted by Fidelis that was showing that Grevillea robusta, okay, near the tree, there is a high level of carbon. The Grevillea robusta tree. Yes. Okay. 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 It's okay. So after conducting the soil analysis, I'll be able to now know the true picture of the soil fertility status around the Grevillea tree for my study. Thank you for your insight. And then I want to respond to the the use of other indigenous trees as opposed to Grevillea. So, okay, this study, prior to this study, I did a characterization of the agroforestry system. So during this characterization, I was able to identify how the farmers were integrating trees within the cropland. And one of the tree that was also I also identified was Mahemia lutea. But now the problem with Mahemia lutea, it was not within the cropland, because one of the things that I was looking at, the tree should be at the center of the farm, should be located at the center of the farm, where I can be able to establish a push-pull around it. But for Mahemia, okay, it was present within the cropland, but it was, most of the Mahemias were being planted at the border of the farm. So the tree that was located in the center of the farm was Grevillea robusta. That's why I settled to use the tree for the push-pull.
So the question was, can other indigenous trees be used in this system?
Yes, they can be used. Like, so long as they don't have the allelopathy, like, so long as they don't have allelopathy. But for a tree like Mahemia, it can also be used, Mahemia lutea.
Just a follow-up on what Prof brought up. I would really want to know, for example, remind us your sample size. How many farmers were involved in this study? Because you've only done one season. Is that correct?
Yes.
And you are confident with those results to present to us or you're looking to publish after this conference, or you going to do the second study before you can be confident to publish?
Okay, thank you. Okay, the results for this study is for the first season. I also intend to conduct the second and third season during the long rains and the short rains, so that after there I can be able to publish. Okay, and then the sample size for my study, I used 10 farmers, 5 farmers from Kisumu and 5 farmers from Vihiga.
And you think that is representative enough? Think about it. Okay. So thank you very much, Elisheba, for your good presentation. Let us applaud her as she takes her seat. As we welcome Garrison Kiprotich. He is going to present on performance evaluation of a solar dryer for, I can't read that very well, but performance evaluation of a solar dryer for Omena. Oh, it's Omena. Enhancing food security through sustainable preservation. This paper is co-authored by Hesbon Ayub and SK Kimutai. Karibu Garrison.
Okay, thank you so much for the welcome. Okay, like it has been said, I'm Kiprotich, and we have also some of my two co-authors, that's Esbon Rasugu and Stephen Kimtai. I'm going to be able to present the performance evaluation of a solar dryer for omena, whose scientific name is silver cyprinid, with an aspect of enhancing food security through sustainable preservation.
Is help coming his way? Oh, as they're trying to sort that out, the next presenter will be Collins Kaisha. So kindly make sure that you've uploaded your presentation to save on time. Is Kaisha in the room? Okay. Do you have your presentation?
You can move the second slide, please, from here.
Clearly, we have a challenge with moving the slides. Kaisha, have you uploaded yours? Can we try?
So I'll proceed. So like the order of my presentation will take the following overview. So I'll go direct to the introduction, whereby I'm going to handle the need for sustainable food preservation techniques, especially for the fishing industry or the fishing drying, as we are aware that we have most post-harvest losses, especially from the other areas such as crops and cereals, but now my focus will be on the fish drying techniques. Yes, we have the older modes of drying, such as smoking, open sun drying. While I'm trying to address the issue of trying to reduce the post-harvest losses by coming up with an solar drying technique. So we have an overview of the drying that exists so far, where we have the methods such as sun drying, smoking, brine and salt drying, solar dryers. So like we all know that this is a type of a small, it is a type of a small family of fish that is normally found in the, for example, in Kenya, it's normally found in the shores of Lake Victoria or Lake Naivasha and some other areas. So there is the need for the design of a solar dryer and also test the performance of the dryer. So this is an overview of the dryer's performance from from research, whereby for you to be able to describe dryer performance, you have to look at the following aspects, such as the drying efficiency. We have also to look at the installation, the heat losses, space. Also, we have to look at the aspects of hygiene, affordability, test, and acceptability index. You also have to look at the color and the texture. So that one is just but a brief overview. So from the overview, you can be able to see that I've been able to get 3 of them. I have open sun drying, smoking, electric oven, and also I have a low-cost solar dryer. So there we have some of the gaps that exist from research. So you also have an advancements in the design of a low-cost solar drying. That's what I'm trying to come up with. We have the material selection, where we use locally available and inexpensive, like bamboo, recycled wood, low-cost materials. We also need to check on the improved air circulation, improved insulation, scalability, which is actually the aspect of how big the dryer is. You also have to monitor temperature and humidity, and also have solar tracking mechanism, among others. So I'm going to go directly to materials and methods. That is the design of the dryer. As you can see, we have the solar collector, we have the trays or the racks, we have the force flow, we have the desk, support stand, and the solar panel, mainly used for harnessing the renewable source of energy. So that is how it has been constructed, where we have the main aspect that has been included there. We have the wood being used as the main material, and the perspex is also there. We have solar collector. So actually, that is the design of the dryer. So the next slide, I'll move to how I was able to conduct the experiment, which I started with what we call sample collection. So in sample collection, I was able to sample 5 sites or establishments along the shore of Lake Victoria, whereby I was able to choose the sites using random sampling method. That is, I was able to pick from those areas randomly. So when it comes to experimental procedure, freshly obtained samples of silver cyprinid were weighed using a digital electronic scale of the capacity, that one. So then I was able to load them into the trays or the dryer racks with a 4 centimeter, approximately 4 centimeter gap between each one of them. As that one, was you had to approximate the gap. So 5 kilograms of omena were evenly distributed across the 3 decks. That is, the higher we have the lowest, the middle tray, and we have the top tray. So also we had under that one, we had to take data after every 30 minutes interval, such as temperature and humidity, so that we could be able to check on the variability as a factor. So there we have results and discussions, whereby we started the first result, which is temperature variation according to time. So from some of the results, like you can see, it started at around 8, whereby it is still early in the morning, and the exercise or the drying exercise ended at 5:35, almost 6. So from there you can see that early in the morning we had low temperatures inside the dryer decks, but as we approach noon, we actually had an increase in temperature and at the afternoon sessions, there was a low record in temperature variation. That also goes hand in hand with the solar radiation, how we had the influence and the variability. So from the results, it is evident that the temperature changes are essential metrics for assessing the effectiveness of a solar dryer. Also, the results indicate that the solar dryer efficiency is significantly influenced by the solar radiation levels. So another aspect I was able to consider is the relative humidity variation, whereby we had what we call the mean ambient. We have the mean inlet and the mean chamber and the mean chimney. Those are just by the sections of the dryer, where we have the ambient. We also have the inlet humidity, the chamber, and the chimney humidity. That's at the exit. So the data that was recorded are just presented there in form of a table, where we had a mean average of 50.44 humidity, percent humidity, and we also have the average chimney relative humidity, that is at the exit, of 39.76. So from that one, you can see that there is a reduction in the humidity. That one shows the aspect of drying. So we also, so from there you can be able to judge that the solar dryer effectively reduces the moisture content of omena by lowering humidity levels inside the drying chamber. So the efficiency of the dryer was calculated and found to be 52%. So also we have got what we call hourly fluctuation in solar radiation versus the dynamics of weight losses. So it is evident that in between 10 a.m. to 14:30, that's around 2:30 p.m., there was a substantial weight loss attributed to intense solar radiation. Since at the start of the drying, we had 5.03 kilograms, and at the end of the exercise, we were able to get 1.68 kilograms. That means that there was that one was arrived when there was no significant changes indicating that the drying limit had been reached. So effect of solar incident variability on temperature dynamics on solar collectors. So also that one you can be able to see that during the morning hours, as we don't have strong solar radiation, so we had around 216 watts per meter squared, but in the afternoon or we have now the maximum value was recorded was 1072 watts per meter squared. So we also checked on the effect of sensory attributes and the overall acceptability index on the drying method. So we were able to check that the optimal coloration signifies the freshness and the proper drying, therefore appealing to customers. So from our experiment, we were able to check that the dried omena meets acceptable standards, as in color, flavor, texture, and smell, David. That one and smell. That one is as per the research that was done by David and Francis in 2023, where David and Francis were able to outline that for you to be able to judge that we have fish or the silver cyprinid meets the acceptable rates of in terms of color and flavor. So we also have solar drying was also preferred over traditional sun drying by more clients. This is because from the evaluation we had a high exercise on. We also see that this attribute has a very high impact on market demand, whereby most of the guys they will buy it if they are only interested. So we have conclusion and recommendation whereby we can conclude that ambient temperature and sun radiation intensively affect the dry efficacy. Also, impact of loss of weight and dynamics are strongly attributed to solar radiation. And then so we also heard that good food handling standards are vital for market success and reduction in post-harvest losses. So further research should be done on enhancing solar design of the collector, whereby we need to check on solar tracking, improved insulation, scalability and modulability, and other aspects. Thank you for listening.
Thank you very much, Kiprotich. In the morning, Prof was asking if engineers have made a pin, and I wish he was here to see that at least we have a solar dryer.
Yes.
You know, isn't it? I think that's that's commendable. So just one clarification from you. I saw in your results the ones on temperature. There was some one that I didn't understand. Can you go back to that slide kindly if you can? And or maybe I missed the explanation. What's about this second slide? I mean the second graph.
The second graph is for temperature against solar radiation.
What's the explanation for this bar that looks like it's an outlier?
Yes, as observed, we know that there is for this aspect of a dryer, we normally observe the aspect of temperature and solar radiation, such that an increase in solar radiation conforms to an increase in temperature. Yes, that one means that if we have high solar radiation, we would have high temperatures in both the inlet and the ambient and also the chamber. That one will also influence the rate of drying. We expect that when we have high solar intensity radiation, we expect the drying time to be lower than when we have smaller or less radiation. Is that clear? I still haven't gotten it very clearly, but it's okay. We can talk about it later so that you explain to me properly. Okay. Are there any questions from the floor? Thank you.
Thank you so much for that very nice presentation. I only wanted to know whether you considered issues of nutrients. When I saw you mention the smell, the color, and all that. By that, would we also be losing a lot of nutrients that is required? Thank you.
Any other question? Okay.
Thank you for your presentation. My question is on the scale of production based on the solar dryer. Would it be more suitable for large scale? And also on the economics of the scale to which the production can be done. Have you factored in the engineering economics in terms of the cost effectiveness for the farmers, or how would it be in terms of when it's the marketability of the project?
Thank you.
Thank you.
Thank you. That's good effort. As you scale, yes, you are likely to run into ability to suck out moist air. Yes. Otherwise, you can cook the fish and then dry it, and you will change the traits of the fish. Yes. Number two, as you scale might need a thermostat. Yes. Yeah. And what is the, you said the moisture content was 1.6 in the dried omena? Yes, that was the weight of the final samples after the exercise. But about the moisture content of the final product? I was able to take keen interest on the weight reduction. Because you are driving out water, yes, it doesn't hurt to say this was the water before and water after. The water after. Yes. Okay.
So,
can I respond
please.
to the question? So I'll start by the first question on the aspect of the nutrients. Actually, that aspect of nutrients would have been also a good area to consider, but considering that my area is in mechanical engineering, maybe I need to get somebody from food science to assist me in the research so that I can be able to see whether also the aspect of drying can be able to, at the event of drying, we may be losing some other important aspects, such as the pH, also the acids, and some other aspects. So that is a commendable insight. Going to take into that one. So I'm also going to answer the question on the scale of production. As I said, we have got an advancement in this one, whereby it comes about scalability, or if it can be able to be used to dry large volumes of omena. So that one is, remember, this one is a model. So after the essence has been found, then this one can be made to cover large extent. Also trying to get into interest of economics is that this one is, like I said before, if you have been able to see the dryer, we have used locally available materials such as wood. We also have bamboo, but the only aspect there that maybe could have been expensive is just but a solar collector. Remember also inside it, like I have not been able to check, just allow me to go back to drawing, whereby we had inside there we have some sensors. Actually, those are the things that we used to measure things such as temperature and humidity ratios. So those are the things that we may factor in the aspect of scale, so that a farmer may be able to leave the old ways of drying omena and get to use the new. So I think up to there, unless there is a question, I'm thankful for that.
Bamboo.
Yes.
Is that the bamboo that you have used?
Inside there we have the racks, we have the dryer racks, like you can see. Inside we have been able to indicate the first floor, we have decks, and those are decks inside are made of bamboo linings at the ends, so that they can be able to also to allow for flow of air inside the chambers.
Yeah, thank you very much. I think we need to appreciate Kiprotich for that wonderful presentation and a good innovation. Thank you very much.
Thank you so much.
So at this point, I want to ask if Gedefaye is in the room. Is Gedefaye in the room? I also want to find out if there is Gidhui Frederick. Gidhui Frederick. And then if they are not there, we move on to, no, I want to ask Damas Wanjiko. Is Damas Wanjiko in the room? Okay. So we will go on to Collins Kaisha. Collins Kaisha is going to talk about assessment of determinants of adoption of BT cotton among smallholder cotton producers in Kitui and Kisumu counties in Kenya. And he is co-authoring this work with Robert Mbeche and Josiah Ateka. Karibu sana.
Thank you. Good afternoon, everyone. My name is Collins Kaisha, and I'm going to take you through our study on determinants on adoption of BT cotton among smallholder farmers in Kitui and Kisumu counties in Kenya. Thank you. So, cotton is a very important crop in Kenya, both in the agriculture and the manufacturing sector. This is because under the agricultural sector, it is able to provide opportunities to almost 50,000 smallholder farmers in Kenya. In terms of manufacturing sector, cotton sector is very important because in the process of one of the pillars of economic revitalization of Kenya is that cotton is an important raw material in the industrial revitalization, the industries which had fallen, such as Rivertex in Eldoret. Cotton is a very important sector which plays in these industries. However, as we can see, that the annual cotton yield in Kenya has declined from the peak of 300 kilograms per hectare to an estimated of 109 kilograms per hectare. This can be shown on the figure shown on the screen. And cotton production has remained low due to several challenges. But key among them, which has been cited by a lot of by Fiber Crop Directorate and the rest of the researcher, is the challenge of pests, and especially a pest called the African bollworm. What can pests result to? Pests attack may result to cotton yield losses of up to 100% losses if not managed. And if managed, literature is showing that it accounts to 30 to 40% of the production costs. And consequently, we have seen that the government has led to the approval of approving the commercial production of Bacillus thuringiensis, also known as the BT cotton insect pest resistant variety. And just to inform you is that BT cotton is a GMO. These are one of the GMO products which are crops that have been approved for commercial production in Kenya. So based on the trials which were conducted, I've shown that what are the important attributes? One is that the trials show that the BT cotton is pest resistant. Second, it reduces the spraying, the number of times sprayed in the season from 12 to 2 to 4 times in a season. It is early maturing, taking 4 to 5 months compared to 6 months the other variety, conventional varieties, and it's high yielding. So you find in a branch it might produce 200 balls per branch compared to the conventional which produces around 30 to 40 balls. That is the cotton lint. High quality fiber. If in the industry of cotton, you find there are two important grades, grade A and grade B, which are very important in terms of the pricing. So most of the studies under this area have been done in the Latin America. It has been done in Asia. But if you see in East Africa, in the Africa and Sub-Saharan Africa, most of the studies which have been conducted only promote the idea of the potential benefits which BT cotton has, but none has shown, and therefore, okay, I'm not moving. Therefore, the study, the objective of this study is what? One is to determine the level of uptake of BT cotton, having considered the important attributes which BT cotton has. And the second objective which we are going to consider are what are the key determinants that are involving or are influencing adoption of this technology among the cotton smallholder farmers. Kindly assist, IT.
This is a battery. You can switch the laptops maybe. Sorry for that. Okay.
So sorry about that. So what is the objective of our study? First is to determine the adoption levels of BT cotton among smallholder farmers in Kitui and Kisumu counties, Kenya. And the second one will be to assess the determinants of adoption of BT cotton among cotton farmers in Kitui and Kisumu counties in Kenya. So which methodology did we use to develop our study? So the methodology used was a cross-sectional survey, was conducted in Kitui and Kisumu counties. A multi-stage sampling was conducted by purposively selecting Kitui and Kisumu counties because the two counties are among the 24 counties which is involved in cotton production. And the second thing is that they are in different agroecological zones, which will enable us to find the variability which could be brought based on their agroecological locations. A total of 389 households were sampled. 242 were cotton smallholder producing household and 147 were non-cotton producing household. The data were collected using in-person interviews, where one-on-one interviews were conducted using a questionnaire, and FGDs and KIIs were conducted. Proceeding with this study, we proceeded with the 242 cotton producing studies for the purpose of this study. In terms of an analysis, we were able to analyze the level of adoption of cotton using a descriptive statistics, and the objective on assessing the determinants of adoption of BT cotton, we used the Heckman two-stage model, where we are able to see factors influencing, one, the need for adoption or not to adopt from a smallholder farmer. And the second model is on the intensity model, which we were able to see the intensity, where the intensity is the land acres, is the ratio between the amount of land which has been allocated on BT compared to the land to the total land under cotton production. So you might find maybe he has grown both BT or conventional variety. So in terms of the results and discussion, we see that the study was able to identify that nearly half of the cotton producing household were involved in farming of BT cotton variety. And among the important demographic characteristics was identified that significant differences were observed in the age of the head of household, farmland, that is the total land which was accessed, the number of crops grown, the size of land which has been allocated by a farmer towards farming, and also cotton productivity and the level of cotton productivity, where from the results you can be able to see that the adopters realized higher productivity of an average of 251 kilograms per acre compared to 195 kilograms per acre to the non-adopters. Also, the total income varied significantly between adopters and non-adopters. Also, another significant difference observed was we were also able to check the wealth index using the principal component analysis, where we identified that majority of the non-adopters were considered as poor compared to the majority of the adopters who were considered wealthy. Also, we were able to see by just asking how they perceive their soil fertility. So those most of the people who conceive their soil fertility as good, that is high or moderate, we were found to be high among the non-adopters among the adopters compared to non-adopters. Also, the level of extension services was found to be significant difference, where majority of the adopters had access extension services. We were able also to assess using a Likert scale on the level of agreement on the BT cotton attributes based on the trials which were conducted previously, but now these are, we want to the confirmation from the farmer. So we found like majority, that is 45.5%, had agreed that BT cotton was resistant. One of the additional characteristics which we wanted also to check was, and also we found that majority, that is 39.5%, were able to concur that it is kind of drought tolerant. 50% concurred that it utilizes less pesticide. In terms of 48% agreed that it is pest resistant, 50% who agreed that it was high yield, and 56% agreed and above agreed that it was early maturity. The question, these attributes were tested among the people who were aware. These are BT cotton adopters, and also the study was able to establish that among the non-adopters, those who were interviewed, 58.27% were aware of BT cotton variety. In terms of checking the determinants which were influencing adoption of BT cotton, we realized that increasing the farming land size, access to extension service, BT cotton attributes, these include early maturity, pest resistant, better quality of fiber, had a positive and significant influence towards farmer adopting BT cotton. The distance to the output market and the perceived soil fertility as good had a negative influence. What could be the reason because of the negative influence towards the soil fertility being considered good? It is because we realize that our farmers are involved in, they normally crop more than one type of crop, especially food crops in this area. And this might because of when a farmer consider a possible experience that when a farmer considers is good, high chances he'll be involved also in food crops. Also, in terms of the intensity, so on the right side is the outcome model, on the left side is the selection model from where you are sitting from. So intensity adoption, we found that household expenditure, access to credit, BT cotton drought tolerant attribute had a positive significant influence. Bigger household size, BT cotton early maturity attribute, crop diversification, and increased access to land had a negative significant influence. I'll talk about the idea of BT cotton being early maturity. One of the things you realize about the study areas is this is a dry area. And important something to note is that the inputs are normally provided to the farmer by the government through 100% subsidy program. And when sometimes these inputs such as pesticide, they normally delay. So this might force a farmer to delay in the spraying program, and which might lead to a negative influence towards increasing the intensity of adoption. What is the conclusion of this study? Nearly half of the cotton producing households households which were interviewed were involved in producing BT cotton variety. And farmer characteristics, economic and institutional factors, and the attributes of BT cotton were found to be a key determinants of adoption of BT cotton among the smallholder farmers in the study area. What are the policy implications of the results? The study suggests that there is need for policy that will lead to the provision, improving and provision of extension services to the cotton farmers through demonstration, farm visits, dissemination of BT cotton seeds, and sensitization meetings. Also, since we identified access to credit to be an important attribute towards increasing the intensity of adoption of BT cotton, Access to affordable and timely credit to cotton farmers will play a key role, especially when it can be either in cash or in non-cash. That is where you are given the inputs in terms of credit. Will play an important role, especially at the production phase, to facilitate the purchase of farm inputs like pesticide and fertilizer. Acknowledgement is that we acknowledge the Department of Agricultural Resource Economics for the support. Thank you.
Thank you very much for that wonderful presentation on BT cotton. Any remarks from the floor? We will only take one because we want to move very, very fast on to the next presentations.
Hello. Nice presentation. I have two questions. Number one, you mentioned that there's a difference between farmers and households that adopt the BT cotton and the other cotton. I'm interested in the economic or the income of these two households. The ones that do adopt, because you say that they have higher yields, how much do they get versus how much do the other type get as income in the market? Number two, you have also said that these cotton farmers have other crops. I'm interested to see what is the ratio. Is there a difference in the ratio and type of crop that the BT cotton adopters have in their farm? For example, if it's a ratio of 2:1, for every 2 acres of cotton, 1 acre of normal crops, and what are they? And then with that, the two categories, is there any significant difference? Because you're talking about poverty levels. Poverty levels, you have to look at the income. You also have to look at where they sell their crops. You have also not mentioned, because you said the non-adopters of a lower wealth. These days we don't say poverty level, we say wealth. I'm forgetting the name, but we don't say poverty level. It was changed in terms of being polite. But anyway, do they have access to different markets that these other non-adopters don't have? Because you've said their poverty level or wealth levels are quite significantly different.
Thank you. Yeah, I think he's gotten the questions. I don't know whether you can be able to respond in 1 minute.
Yes, I'll be able.
In 1 minute.
Yes. Thank you. So the first question you have requested to check. So one of the things we are going to assess is that on the future study which we are working on is an assessment on effects, because just from the comparison only we cannot be able to establish scientifically that there is an effect. So the study which we are not working on it next is on the effects of adoption of BT cotton on profitability and productivity. Thank you. So that's the first question. The second question you have asked is on total income. So, sorry. So it's okay. I can still answer it. So the comparison when we were conducting analysis of the wealth index, we used an analysis was conducted using a principal component analysis. Principal component analysis, we were able to observe important productive assets in the household. So from that, we are able to get the study was able to clarify the farmers into 3 important categories. That is, if individual had high value assets, was considered as a wealthiest, then moderate, then poorest, representing like a low tier individuals in the society. Coming back to the idea of the number of different varieties. Yes, it was captured under the descriptive statistics, where you can be able to see the number of crops grown. That is if you can be able to see, let me see, the number of crops grown. So we were able to see the number of crops grown by the different categories. And maybe for future we can be able to show the ratio, so that we can be able to see what's the difference. Maybe the idea will be the one with more crops was significantly likely not to be involved in the BT cotton adoption because of the result of the land ratio.
Thank you very much.
Thank you.
I think maybe if she's not satisfied, you can continue the conversation over lunch hour. At this point, we want to find out if Ireri Langat is in the house. Is Ireri here? Alaric Brown? Zacchaeus Kajita? Grace Njuguna? Evelyn Chepngetich? Maureen Akinyi? Chepngetich Naomi, and then lastly Teresia Njeri. So at this point, I would want to invite the chair for this next session, Dr. Maina. You're welcome. Thank you very much for your cooperation, and let's please listen in to the rest of the presentations before we proceed for lunch. Thank you. Those that we have mentioned their names, can you please load your presentation kindly? You've already loaded your presentation? Okay, they have. Oh, there are six. Yeah, there are six. The discussion. I think they are better models.
We have a choice to make, and the choice is that we want to have the presentation come. And what we are going to do in order for us to save ourselves from the stricture of time is we are going to have the presentation come, and then we shall have a panel discussion at the end of the session, and that way we'll be able to save some time to allow each one of us perhaps to ask a question, and therefore to move for lunch and still be here 2:15 for the closing ceremony. So my name is Maina, Dr. Maina Ngotho. I work in the Animal Sciences Department, JQuat, and we are here to listen to the talks with respect to agriculture. And I would like to invite the very first presentation. Who is ready with their presentation? Ireri, are you here? Ireri? Kindly. Next, of course, we shall have Grace. Is Grace here? Aha, good. After Grace, we shall have Ireri, you should be on the podium. Evelyn? Excellent. And then we have Alaric. Is she here? After then we have Maureen. Excellent. Then we have Zacchaeus. Zacchaeus? No. And Naomi. Good. Let's have the first presentation by Ireri, and he's going to talk to us about factors influencing adoption or push-pull technology among the smallholder cereal farmers of Eastern Africa. You shall allow up to 10 minutes maximum. then we cut you out.
Okay, thank you, Chairman, for the opportunity. So I'm carrying out a study, as has been said, factors influencing the adoption of push-pull technology among smallholder cereal farmers in East Africa. And this is a project under the upscale in East Africa, taking place in 5 countries, that is Ethiopia, Kenya, Uganda, Rwanda, and Tanzania. My co-authors are Langat, Murage Alice, and Obari. Ever since we have realized there is slow productivity when it comes to cereal production, and this is as a result of weeds, striker weed, we have cereal tempora, fall armyworm, and due to poor and degraded soil, this has lower productivity, resulting to increase in market price of these cereals. To improve this productivity, in a development of intensification, that is practices to improve productivity of cereal in Africa, and adoption of various technologies. One that has been developed by the International Center for Insect Psychology and Ecology, that is ICIPE, 1997, introduced this technology in Kenya to increase cereal production overall in Africa. And this technology is known as the push-pull technology, which control tempora, striker weed, and fall armyworm simultaneously. This technology also improves soil fertility and allows intensification of farming among smallholder farmers. This technology, as you have seen, it has many benefits to farmers and communities. And despite these reported benefits that has been documented on the impacts, its full potential has not been realized, mostly in Eastern Africa. And there is need to reach to these many actors, and it's important to understand the adoption process. Previously, we have understand adoption of technologies just being adopter and non-adopter. But now, understanding this adoption process by smallholder farmers, we reduce adoption in understanding the process of adopting this technology. For instance, if a farmer is consistent user, if it is inconsistent, semi-consistent, or dropout, or trialers. Thus, this will generate evidence that can guide the intensification of cereal production. And that's what I was describing, the adoption process. This is the decision tree diagram. At the far end, we have the sample farmers. We have those who are aware about the technology, those who are aware, and those who are not aware. And when you come aware about the technology, you come further, you can be interested or not interested regarding this technology. And if you are interested, you either try or continue using. And when you continue using, we will get farmers who will consistently use this technology. There are those, the semi-consistent, those who will use this technology maybe for this year and next year, they drop out. We have inconsistent. You find that they use in 2015, they will not use in 2017, they will. And all this from inconsistent, semi-consistent, and consistent, we will have the dropouts and the expansion. Maybe I can explain a little about expansion. Expansion comes in whereby if a farmer has already adopted this technology, expansion means it can increase the number of plots or the area under push-pull technology. And this is the adoption grouping in East Africa. The consistent use, the consistent, we have inconsistent, we have trialers, we have dropouts, uninterested, and expansion, and those who are unaware about the technology. Kenya, Uganda, Tanzania, Rwanda, Ethiopia, giving a total of 1,556 respondents to our study. And in the methodology process, as I've said earlier, it was conducted in Eastern Africa under the project Upscale, where in Ethiopia we had the North Shewa, Oraima, Son, South, well in Amara. In Kenya we had the county of Kisumu, we had Vihiga, Siaya, and Homa Bay counties. And in Rwanda, that is the Nyagihaya sector. Tanzania, we have Butiama, and Uganda, Iganga, Kamuli. And in the process, to understand those inconsistencies, consistent, semi-consistent, we adopted the multinomial logit model to understand the factors influencing this adoption. And there you can see the farmer characteristics that influence these various levels of adoption or the adoption process. For instance, you find gender being significant in terms of farmers who are consistent and inconsistent, trialers, dropouts. Technically, in all the adoption process, gender is significant. But in terms of consistent, yeah, it's negative throughout the process. When you come to age, age is significant throughout the process except in expansion phase, and education is significant through all other processes except the trialers, not the trialers, inconsistent users. The same with household, it's only significant in consistent the inconsistent users and in the expansion phase. The same case applies to all other farmer characteristics. There we have the significant values varying across all the processes. TLU means the tropical livestock units, which was also significant across all the adoption process except in trialers. We have market access, which was insignificant throughout the process. We have the dummy, here being a dummy variable, which was significant in inconsistent trailers and dropouts. So technically, this output shows that there varies level. Not only understanding the adopters and unadopters, we need to understand this push-pull technology. What is the process for research? For instance, research institutions, government institutions, there is need to come together to address the adoption process. For instance, in terms of inconsistencies. And the last part being, there is need to improve extension services for sustaining this adoption. I would like to acknowledge the European Union for their funding of this project. Also, I acknowledge the country coordinators, both in Kenya, Rwanda, Uganda, and Ethiopia, and enumerators who farmers, and finally, the upscale stakeholders who in this project. Thank you.
Thank you very much, Wanaireri, for saving us half a minute. We appreciate that. As we said, members, kindly take note, and we shall have a panel discussion at the end of the session. So we now want to invite, let's give Ireri a clap as he goes down. We want now to invite Grace, and take you from our good friend Ireri and save us a little time. Grace will give us a talk on fisheries freshness with respect to compounds in tilapia.
Thank you.
Yes, thank you very much. And sorry for the small technical hitch. So my presentation is on fish freshness sensing using changes in fluorescence compounds in tilapia eye fluid. So globally, we have more than 2% cases of food insecurity, and this is as a result of inadequate, post-harvest losses that are due to the inadequate equipment to be able to sort out these losses. And there are several methods that have been used in the recent past on fish freshness determination. Some of them are sensory, which are a bit subjective. The others are chemical analysis, which sometimes take too long. And the other one is the physical measurement. So, due to the current increase in population that you are all aware of, there is need to be able to look for other alternatives of sources of food. And in this case, when we talk about protein, we are looking at fish. And this fish is it has high nutritive and economic value. So there are modern technologies that need to be developed to be able to improve the shelf life of fish during storage in order to safeguard food security. So in terms of fish, the most important thing is the quality, which also improves the ability to be able to sell and also the consumption of fish. So major things that affect the spoilage of fish. One, we have the autolytic spoilage that takes place. We have the microbial spoilage and also the chemical spoilage. From a point of view of looking at some of the parts of the fish that are responsible for the spoilage, you look at the eye. When a fish is fresh, it will be clear, but when it is spoiled, it becomes cloudy. When you look at the skin, it's very bright, but when it is spoiled, it becomes dull. The outer slime is absent, but at spoilage it's very slimy, and the smell also changes, whereby we have a fresh fish having an aromatic smell, but a spoiled one has a very not good odor. Then when you talk about fluorescence, it's a very fast and simple way of assessment, where we have in this case being explained by the Jablonski diagram. And in this diagram we have the photons moving from the singlet ground state onto the first singlet energy state, and then back to the singlet ground state. So 30% of the fish and a quarter of the food supplied in the world get spoiled because of microbial spoilage, and this is whereby the microorganism invade the food, hence the spoilage. So some of the things to be able to measure whether fish is fresh is subjective, whereby we have a few people getting to understand how you can be able to know whether a fish is fresh or not. And some of these methods, for example, using the fluorescence spectrometer, are very expensive and are not available to the common farmer. And the development of some of the most effective and rapid method would be very essential for farmers and even traders in the market. So in order to achieve this, we need to identify and monitor changes of fluorescence compound in the eye fluid. And in this case, we are dealing with tilapia fish. And Determining the presence of this fluorescence compound is key, and identifying which specific compounds they are, and again monitoring how they change as spoilage occurs. So for the procedure taken, there was the collection of the fish from Makindo Fish Farm in Muranga. Then there was annihilation of the fish, and then the extraction of the eye fluid, and also the lab analysis. So for the first one, the determination of the fluorescence compound, there was need to, what happened is that the storage was done for 72 hours, monitoring and collecting of data for every 24-hour interval of storage. Then the sample was centrifuged for about 5 minutes at 3000 RPM to be able to obtain the spinactant, and this is what was subjected to the UV VIS. And what was observed from this is that there was the low intensity of as the components broke down, the aromatic amino acids were breaking down into a uric acid, and that's why we had emissions. Then the amino acid also were breaking down into uric acid. Hence, we had, at the beginning, we had high intensity, as high as 4.3 candela, and the wavelength went up to 570 nanometers during storage. So in terms of determining the fluorescence compound, in this case, governed by prior research, we mostly focused on two, that is vitamin A. And in this case, we used HPLC. So after obtaining the...
You have 2 minutes, so kindly conclude.
Okay, thank you. So after... Yes. So from there, we were able to identify vitamin A being present, that is the retinol, and it increased at some point. Then as the storage and the breakdown of the compounds, the concentration reduced. Same case happens to vitamin B6, and this is because of the changes in aromatic amino acids through the biochemical reactions, and this resulted in the conversion to uric acid, and this was observed as it was stored for the 72 hours. So in terms of conclusion, our study concluded that there is a correlation between the eye fluid fluorescence and the tilapia freshness, and this breakthrough aligns with the global endeavors to enhance food security and to be able to minimize post-harvest losses. And for the recommendation is further optimization to be able to have refining the methodology to enhance accuracy and efficiency. Also, large-scale implementation of this, in addition to development of a sensor that can be able to be used by small-scale farmers and even traders in the market, which is the second part of the project. And thank you for your attention.
Thank you, Grace, for keeping time. You have only about 5 seconds to the completion. We thank you. Tumpigie makofi as she takes Kindly take your seat, and then we wait for the presentation from Evelyn to tell us about climate smart agriculture and livestock farming. Grace. Evelyn, sorry.
Okay, so thank you very much. My name is Chepngatich, and I'm going to present this paper about the effect of knowledge and perceptions on uptake of climate-smart agricultural practices among the livestock farmers. This work has been co-authored by Dr. Ateka, Dr. Mbeche, and also Dr. Obebo. So as we all know that about climate change, there's been a lot that you've heard about climate change and the havoc that it has caused globally. And some of these havoc include the livelihood instability, the decline in productivity that will lead to food insecurity, and also so many other things that have really caused a lot of problems in the world. Although this is a phenomenon that is worldwide, and it is something that is affecting most of the parts of the world, there are some areas in this world that are more affected than others, and these include the sub-Saharan African, where the reason why it is mostly affected is because of the reliance on agriculture as the only source of, or the main source of their livelihood or their economic growth. And this agriculture, which is the source of the economic growth, is rain-fed, meaning it is affected by this. Anything that will touch on the climate, which is dependent, will be affecting agriculture in a big way. And also, we've also heard about the projections that have been made by the IPCC about the future climate change, which will be intensifying, and meaning that these regions which are mostly severely affected will still bear the same brunt of being severely affected by the climate change. And so there have been a lot of consultation around the world on how we can be able to go about these climate change issues. And there is the proposed mechanism which can be used in reducing the effect of this climate change, which is the climate smart agricultural practices that can be adopted by the farmers so that they can be able to help. And this is because of the three proposed or three objectives of these climate smart agricultural practices, which is sustainably increasing food security or income, productivity, and also adaptive capacity and resilience of the farmers is being increased through this climate smart agricultural adaptation, and also the mitigation in terms of reducing the greenhouse gas emission. And and we also look at, when it comes to now Kenya, let's now come home and see how this climate change is affecting us. We know that many parts of the Kenya is found within the arid and semi-arid regions. That is actually 85% of all the Kenya land is within that region. And this is the region where it hosts about 70% of the total livestock, meaning the livestock in this region is a key source of livelihood. And because of that, these regions have also been affected so much by the climate change, meaning they also affect the economic growth, the rural income, and the food security of people living in this region, and those actually depending on this livestock. And so with this, there is also, Kenya have also, in a way, also embraced these as climate smart agricultural practices by making sure that they have also formulated policies around those climate smart agricultural practice adoption to be able to upscale and accelerate the adoption of these practices. And through the various policies that have been put forth, but as you see by the research that has shown that despite all these efforts that the government has made, there is still very low adoption of these practices, even despite the benefits that have been spelled out to be. So research have also shown, maybe there has also been research that has been done on why are these adoption rates very low. And most of the research that has been done has been mainly concentrating on the socioeconomic, institutional, biophysical factors, and there have been very little attention given to maybe some of those factors like cognitive factors. And in this case, I mean the psychosocial or psychological factors that goes about the reasoning in terms of the decision making within the adoption of these practices. And why do we talk about these cognitive factors? These cognitive factors, we found that when we talk about the adoption is not just an activity that can just take place by just looking at something and then you decide. it has to go through the mind of the farmer and also make up that decision whether to want to adopt or not adopt a practice, or even adopt sometimes, and you can even discontinue with the practice. So there is a lot that has to go into the mind, and this can be influenced by the knowledge and the perception, even of the climate change, apart from even the perception about the practices themselves. So this has also been found to be very influential by other researchers in other quarters also, and we want to test this now in terms of the farmers and particularly within the livestock sector, and see how it's going to affect.
It will be much better if you dealt with the results and the conclusions, so that we allow one more person to speak.
Okay. So we are going to look at the effect in this using 10 practices within the livestock farmers. So this study was done in 3 counties, that is Laikipia, Kajiado, and Taita Taveta. And we also looked at the knowledge and the perception, which was measured using some statements that were given to the farmers, and then they were analyzed and generated, index generated using the PCA. And also, we also took a look at the adoption of the practices, the 10 practices that I said. Those practices were around the nutrition and health, around the breeding, around risk management. And we also did a descriptive statistics in terms of how the adoption rates were within the different counties. And then we used multivariate probit model to be able to test now the effect of these, and that is the knowledge and perception, together with other control factors, which now include the institution, socioeconomic and other factors, and see how they were going to affect the adoption of these, or the uptake of these particular practices. So from the descriptive analysis, we looked at the adoption across the 3 counties, and we've seen that the adoption rates were shown there. And there were so many practices that were low. I can say low because there were some which were 40, slightly 50. And the highest, maybe in terms of the counties, we found regular vaccination being very high within Kajiado County. And then others were very low as 17% for the conservation. From the multivariate analysis, we also looked at the effect now of this particular, and of our particular interest was the cognitive factors, that is the knowledge and perception. And in this case, we divided perception into 2. We had perception of the parameters, that is perception about the temperatures, and mainly temperatures and rainfall. And then now a perception about the impacts of climate change, particularly on their livestock production. And so we looked at that, and we realized that with the nutrition and health management, knowledge only influenced adoption of one practice, while we have the perception of parameters and perception of impacts influencing a number of practices, as shown there. We also have, in the case of breeding management, our variables of interest also, knowledge did not affect any adoption of any. That was not significant in affecting the adoption of any, while perception and perception of impact and parameters was still very significant. When it comes also to the risk management practices, we also realized that knowledge was also just affecting 1 out of the 4, while the perception of parameters and also perception of the impact was influencing a number of those practices. So what is the conclusion here? We've concluded that as much as we talk about other factors that are there that can be able to influence adoption of the CSA practices, there's also need to consider maybe these cognitive factors, and especially the perception in which the farmers have around the climate change and even around the climate impact. So that now, because you have found from our study that it really have a very big impact in terms of influencing the adoption of most of those practices that we tested in the study. And so as a recommendation, maybe the government should be able to invest in meteorological department, information sharing to the farmers, so that they can be able to have that accurate weather forecast information. And this will help the farmers in actually having trust with the meteorological data, and also being able to form the perceptions about the climate change in terms of the parameters, which we have seen is very important. It's also good to enhance the livestock farmers' understanding in terms of the climate change impacts. And sometimes maybe we think about could there be some farmers who may be looking at, there are so many problems that they encounter in their production, but they are not linking those problems to climate change. Maybe we need to sensitize the farmers in terms of what are some of the impacts or we find when we have climate change. And then in that case, it will be able to help the farmers to understand that they have a problem, and therefore when we come in with these trainings and sensitization about the adoption of these CSA practices, they'll be fast to adopt because they understand that we have a problem that can be solved through these CSA practices that have been floated for them to adopt. Thank you very much. This work, we acknowledge Forum and Konagi Foundation for the funds for using in this project, together with Kenyatta University and also Jomo Kenyatta University.
Thank you, Evelyn. Thank you very much for reminding us about the smart weather, the smart climate. Our last presentation, or is it not, is Maureen. Maureen, kindly. And I hope you have learned from the rush we are engaging in. Makofi kwa Evelyn, tafadhali. Thank you. Thank you. We will talk about that. Let's have this one first. So, Maureen, take it away.
Good afternoon. My name is Maureen, and I'll be taking you through the evaluation of chemical and physical characteristics of the baobab pit and the effect on the growth and development of the lettuce. And my co-authors are Dr. Madivoli, Dr. Ngamau, and Professor Kareru. So on to my introduction, we all know about climate change. It's really been discussed. And we know that it's causing pronounced effects on various sectors, and therefore it is important for us to have adaptable and sustainable solutions. So hydroponics, which is also known as a soilless culture, is gaining significant popularity, and it's an area that we need to continue to build on in order to combat the endless droughts and floods. So baobab bio-waste is it comes from the baobab fruit. The baobab fruit is as shown in the picture and 70% of that fruit goes to waste, and the rest is used as baobab seed and baobab oil. Sorry. So continuation, with the heightened interest in the baobab industry, this baobab waste can be used, can find proper use, and if it's left, it can be a menace. So, and therefore the baobab fruit industry has not been exploited so far, and therefore this study sought to establish the potential fruit, herein referred to as the baobab pit, as a growth medium in hydroponic vegetables production in a case study of lettuce. So other bio-waste which have been previously used include the coffee ground, sawdust, eggshell, and cocoa peat. So my statement of the problem is the unpredictable weather patterns which are wreaking havoc worldwide, and they're causing a decrease in food production, and therefore leading to food crisis, food insecurity, and malnutrition. So my objectives were to determine the physiochemical characteristics, that is the nitrogen, phosphorus, and potassium concentration, the pH, tap, bulk density, lignin content, cellulose content, moisture content. And also I was to determine the effects of leaching of fertilizers on the baobab pit by adding phosphorus, potassium, and nitrogen in it, and give a comparison between the yield in the growth of lettuce using another media such as the cocoa peat. So the sample collection was done at Vokenel Limited, which is a local company. It's located in Makueni County. And we also interviewed the staff and the local farmers. A random sampling design was used, and the samples were crushed and segregated and harvested. And therefore the physiochemical analysis was done. Sorry. So my methodology was, for the analysis of the lab, was just drying at around 105 degrees and then storing for the analysis. So the analysis include the pH, the electrical conductivity, moisture content, bulk and tap density, cellulose, and lignin content. And thereafter, I moved to the greenhouse experiment, where I wanted to find out the effects of the baobab pit on the growth and development of the lettuce plant. Those are the results of my physiochemical characterization. As you can see, this is in comparison to the growth media optimal range, and most of them comply except for the total carbon content, the available phosphorus, which is quite high, and as well as the potassium. And the bulk and density also, bulk and tap density were also recorded to be low. I was also able to compare my results with other growth media such as the coconut coir and the peat moss, and you can see that there's no significant difference observed except for the moisture content, the lignin content, sorry, and maybe the total phosphorus. The greenhouse experiment constituted soaking of the media and then having the progressive washes, which I was constantly checking the EC so that it can reach the optimum level for a growth media. This was done for both media, that is the coconut coir as well as the baobab pit. So the seeding was done, and thereafter you can see the seed sprouting after germination, and then the percentage germination was calculated, and then transplanting took place after the 4th week. And the media were mixed in different ratios, and those ones were my treatment. So we had the ratios of 1:1, 2:1, 1:2. And you might ask why I chose lettuce. Is because lettuce takes a shorter time for growth as compared to other vegetables. And this, since this is a novelty, I just decided to start with lettuce. Then maybe I might consider the other vegetables. So those ones are the results of my germination. And I was also, after harvesting, I was able to do the fresh weight versus the dry weight of the plant, and those are my results. As you can see, they're varied. In conclusion, the analytical results of the baobab pit complies with what is required for growth media, and therefore it also compares closely to those of the coconut coir and the peat moss. And there's need also to exploit with other vegetables such as the tomatoes and just see how well it will do with them. And the baobab pit showed to be a promising growth media, which can be further employed as an alternative growth media for crops amidst the climate changes. Those are my references, and special thanks goes to my supervisors, JICA, Vocanel. Yeah, and thank you, participants.
Thank you very much, Maureen. You have saved us 3 minutes, so that allows us to listen to Teresia. And we need to be out of here by 2:10, and it's already 2 o'clock. So Teresia, and still need to have a Q&A. Teresia, kindly just tell us what we must hear, so that we allow time for people to interact with the session presentations. Thank you.
Good afternoon. My name is Teresa Njeri. I'm presenting on macroinvertebrates and carbon stocks, ecosystem services in agricultural systems. So the agricultural systems are expanding. This is because the human population is increasing. And so here we need to see how we can make the systems provide ecosystem services and at the same time provide food. And so the macroinvertebrates are important. They are engineers and they affect many ecosystem services in the soil. One of the important ecosystem services is the carbon, the soil organic carbon, which mitigates global warming. So the amount of carbon stocks and macroinvertebrates can be influenced by the agricultural practices. The objectives are to assess the abundance and diversity of macroinvertebrates, and also to quantify the carbon stocks, the soil carbon stocks, in differently managed agro-ecosystems. And so we are calling this conservation and conservation agriculture. And conservation agriculture is where the farmers make use of soil, the fertilizers. They use organic fertilizer, they practice intercropping, they use manure from the farm. So we call that conservation agriculture. And then on the other hand, non-conservation agriculture is where they use the normal fertilizers, the inorganic. They don't practice intercropping. And so that aside, we call it non-conservation agriculture. And so we identified the farms, the tea, coffee, and banana farm, and we sampled for the invertebrates, and we also sampled for the soil carbon. We sampled for the soil carbon, and for the soil carbon, we estimated the soil, the carbon concentration and the bulk density, and then we used this formula by Murphy to estimate the soil organic carbon per hectare. We assessed the abundance of the macroinvertebrates in the different farms. So you can see there we have the banana farm, which had more of the termites there. We have also the Lumicidae and then the Formicidae. And there we can see that the banana farm had more of the macroinvertebrates than the other two. These are some of the macroinvertebrates that were picked during the sampling. And these are now the means of the macroinvertebrates in each of the treatment. So we have the conservative or the conservation agriculture, and we have the non-conservation agriculture, where we have a mean. And again here we see that the mean is higher in the banana farm, both the conservation and non-conservation. But we notice that for all of them, the conservation agriculture has more macroinvertebrates, and it was significant. That was significant. So we checked the distribution of the macroinvertebrates along the depth from 0 to 30 centimeters, and 0 to 10 centimeters had significantly more macroinvertebrates than the other depths. The density, the density and abundance reduced as you went down the depth. And also we have the carbon stock ecosystem services, and we can see that banana has more carbon stocks compared to the coffee and the tea. The depth was not significant. The distribution, the difference in the carbon stocks from one depth to another was not significant. The correlation between the invertebrates and between the macroinvertebrates and the carbon was positive for the banana farm.
It was negative for the coffee and the tea farm. Yes, so the farmers usually interact more with the banana farms, because the bananas are usually closer to the homesteads, and that is what could have led to the higher numbers of macroinvertebrates and also high quantities of the carbon stocks. So we have done comparison with other studies. They have shown that there is a correlation with the soil carbon stocks and macroinvertebrates. Also, the decrease with depth is also consistent with other studies by these researchers. And then in conclusion, we see that agroecosystems are important as habitats of macroinvertebrates, and also are important in conservation of carbon stocks. And this can be enhanced if the conservation agricultural practices are used. And so there is need to have more increased awareness among the farmers on these practices, and then also a need to expand the conservation agricultural practices. Yes, thank you.
Thank you very much, Trecia. Tumpatie makofi. As you can see, we had a lot of pressure because the next session is supposed to start at in 5 minutes time. So we'll allow, if there is a burning question that we must respond to the 5 presentations. If there is somebody who really must have an answer or a response to their query, I have a lot, but I think I want to donate mine. There's a hand up there. Is there any other? Very well. At least there will be, and please kindly indicate who to. Thank you.
Thank you, Chair. Mine is not a question, it's a clarification. It's good to maintain research ethics. When I was presenting, I never mentioned I am standing in for Dave Ireri, and you refer to me as Dave. My name is Dominic Kipngeno. I was standing in for Dave Mwangi. Yeah.
My apologies. But you did a good presentation on his behalf. Thank you. Very well. In the interest of time, I was going to ask Grace. I don't know whether she is here or she is. I was going to ask you. You talked about. I was going to ask you about the way the communities have always done their fish identification of how fish is identified as spoiled or not before you go to the high level university kind of identifying. Respond to that.
Yes. What I meant is if, for example, I have worked in Kipini, and we were doing a lot of fish evaluation, freshness evaluation, and even storage. And you find that even for you as an individual, how would you identify that a fish is fresh or not? It is a bit subjective. Mostly you find that fish farmers, sometimes they might touch the surface of the fish. Sometimes they to just feel the slime. Sometimes they might just look at the eye to see whether it's cloudy or not. And sometimes something that is very common to those who eat fish is the scent. And you find that sometimes we are not able to identify a fresh fish from the scent because we are just used to a specific scent. If you take a fish from the pond or from the lake and just eat it, it will be different in terms of the the scent. There is a common thing that goes around that when you take fish at Lake Victoria, just near the lake where they just they dry them and they pre-cook them, it's the taste is much better than if you take the same fish and transport it to Nairobi. Yes, I hope I've answered you.
I was trying to go back to the talk that we had yesterday from Professor Biaruguba, and I think it's a good thing to go back to the indigenous knowledge. Yes, it is subjective, but nevertheless, I think it will be something nice to form the background of what it is that you're doing, because then we would be able to grow from where we were told about the womb university. Ladies and gentlemen, we want to leave it at that because we must allow the next session to start. I wish you to thank you very, very much for at least keeping us company and the presenters for coming on board. We wish you well as you do your science going forward. And we pray that even though it was not discussed, you had the pleasure of making yourself heard. We want to particularly appreciate our rapporteur. She had, I think, the longest of the long sessions. Tumpatie makofi for her. Thank you very much, Elvin. And bon appetit. And please be back for the closing ceremony. Thank you very much.
Guided by a clear vision as a university of global excellence in training, research, innovation, and entrepreneurship for development. The university has a diversity of academic programs, research and innovation enterprise. JKU Art has 5 colleges offering over 400 academic programs. The colleges are Engineering and Technology, Pure and Applied Sciences, Health Sciences, Agriculture and Natural Sciences, and Human Resource Development. Since its inception, JKU Art has been at the forefront in fostering a culture of research and innovation among faculty and students. The university's modern teaching and research infrastructure, as well as a blend of local and internationally sourced innovative students and qualified faculty, gives JKU Art an edge in facilitating the attainment of Africa's development aspirations. Besides, JKU Art is proactive in Africa's development mainly through various research initiatives. In 2012, for example, JKU Art won a competitive bid to host the Pan-African University Institute for Basic Sciences, Technology and Innovation, a graduate hub that has thrust JKU Art at the center of Africa's integration and development through graduate training and research. The establishment of various centers of excellence through its extensive collaborations and partnerships with government, academia and industry has been instrumental in supporting incubation of research into viable commercial ventures that are beneficial to society. Due to this, more top-notch research enterprises at JKU Art have earned the university a much-needed prestige not only in Kenya but in sub-Saharan Africa. JKU Art is, for example, home to the Legume Center of Excellence for Food Nutrition Security, Cassava Virology Lab, EU-funded Food Fortification Lab, and Innovation Prototyping Center, among others. JKU Art is also host to the China-funded Sino-Africa Joint Research Center, which has been at the forefront in advancing biodiversity research and conservation in the continent. In addition, JKU Art is home to Africa's only international maritime technology cooperation center fronted by International Maritime Organization to champion research in the emerging blue economy. With an enrollment of over 35,000 students, JKU Art is currently repositioning as Africa's leading entrepreneurial university. Jomo Kenyatta University of Agriculture and Technology is guided by a clear vision as a university of global excellence in training, research, innovation, and entrepreneurship for development. The university has a diversity of academic programs, research and innovation enterprise. JKU Art has 5 colleges offering over 400 academic programs. The colleges are Engineering and Technology, Pure and Applied Sciences, Health Sciences, Agriculture and Natural Sciences, and Human Resource Development. Since its inception, JKU Art has been at the forefront in fostering a culture of research and innovation among faculty and students. The university's modern teaching and research infrastructure, as well as a blend of local and internationally sourced innovative students and qualified faculty, gives JKU Art an edge in facilitating the attainment of Africa's development aspirations. Besides, JKU Art is proactive in Africa's development mainly through various research initiatives. In 2012, for example, JKU Art won a competitive bid to host the Pan-African University Institute for Basic Sciences, Technology and Innovation, a graduate hub that has thrust JKU Art at the center of Africa's integration and development through graduate training and research. The establishment of various centers of excellence through its extensive collaborations and partnerships with government, academia and industry has been instrumental in supporting incubation of research into viable commercial ventures that are beneficial to society. Due to this, more top-notch research enterprises at JKU Art have earned the university a much-needed prestige not only in Kenya but in sub-Saharan Africa. JKU Art is, for example, home to the Legume Center of Excellence for Food Nutrition Security, Cassava Virology Lab, EU-funded Food Fortification Lab, and Innovation Prototyping Center, among others. JKU Art is also host to the China-funded Sino-Africa Joint Research Center, which has been at the forefront in advancing biodiversity research and conservation in the continent. In addition, JKU Art is home to Africa's only international maritime technology cooperation center fronted by International Maritime Organization to champion research in the emerging blue economy. With an enrollment of over 35,000 students, JKU Art is currently repositioning as Africa's leading entrepreneurial university. Jomo Kenyatta University of Agriculture and Technology is guided by a clear vision as a university of global excellence in training, research, innovation, and entrepreneurship for development. The university has a diversity of academic programs, research and innovation enterprise. JKU Art has 5 colleges offering over 400 academic programs. The colleges are Engineering and Technology, Pure and Applied Sciences, Health Sciences, Agriculture and Natural Sciences, and Human Resource Development. Since its inception, JKU Art has been at the forefront in fostering a culture of research and innovation among faculty and students. The university's modern teaching and research infrastructure, as well as a blend of local and internationally sourced innovative students and qualified faculty, gives JKU Art an edge in facilitating the attainment of Africa's development aspirations. Besides, JKU Art is proactive in Africa's development mainly through various research initiatives. In 2012, for example, JKU Art won a competitive bid to host the Pan-African University Institute for Basic Sciences, Technology and Innovation, a graduate hub that has thrust JKU Art at the center of Africa's integration and development through graduate training and research. The establishment of various centers of excellence through its extensive collaborations and partnerships with government, academia and industry has been instrumental in supporting incubation of research into viable commercial ventures that are beneficial to society. Due to this, more top-notch research enterprises at JKU Art have earned the university a much-needed prestige not only in Kenya but in sub-Saharan Africa. JKU Art is, for example, home to the Legume Center of Excellence for Food Nutrition Security, Cassava Virology Lab, EU-funded Food Fortification Lab, and Innovation Prototyping Center, among others. JKU Art is also host to the China-funded Sino-Africa Joint Research Center, which has been at the forefront in advancing biodiversity research and conservation in the continent. In addition, JKU Art is home to Africa's only International Maritime Technology Cooperation Center, fronted by International Maritime Organization to champion research in the emerging blue economy. With an enrollment of over 35,000 students, JKU Art is currently repositioning as Africa's leading entrepreneurial university. Jomo Kenyatta University of Agriculture and Technology is guided by a clear vision as a university of global excellence in training, research, innovation, and entrepreneurship for development. The university has a diversity of academic programs, research and innovation enterprise. JKU Art has 5 colleges offering over 400 academic programs. The colleges are Engineering and Technology, Pure and Applied Sciences, Health Sciences, Agriculture and Natural Sciences, and Human Resource Development. Since its inception, JKU Art has been at the forefront in fostering a culture of research and innovation among faculty and students. The university's modern teaching and research infrastructure, as well as a blend of local and internationally sourced innovative students and qualified faculty, gives JKU Art an edge in facilitating the attainment of Africa's development aspirations. Besides, JKU Art is proactive in Africa's development mainly through various research initiatives. In 2012, for example, JKU Art won a competitive bid to host the Pan-African University Institute for Basic Sciences, Technology and Innovation, a graduate hub that has thrust JKU Art at the center of Africa's integration and development through graduate training and research. The establishment of various centers of excellence through its extensive collaborations and partnerships with government, academia and industry has been instrumental in supporting incubation of research into viable commercial ventures that are beneficial to society. Due to this, more top-notch research enterprises at JKU Art have earned the university a much-needed prestige not only in Kenya but in sub-Saharan Africa. JKU Art is, for example, home to the Legume Center of Excellence for Food Nutrition Security, Cassava Virology Lab, EU-funded Food Fortification Lab, and Innovation Prototyping Center, among others. JKU Art is also host to the China-funded Sino-Africa Joint Research Center, which has been at the forefront in advancing biodiversity research and conservation in the continent. In addition, JKU Art is home to Africa's only international maritime technology cooperation center fronted by International Maritime Organization to champion research in the emerging blue economy. With an enrollment of over 35,000 students, JKU Art is currently repositioning as Africa's leading entrepreneurial university. Jomo Kenyatta University of Agriculture and Technology is guided by a clear vision as a university of global excellence in training, research, innovation, and entrepreneurship for development. The university has a diversity of academic programs, research and innovation enterprise. JKU Art has 5 colleges offering over 400 academic programs. The colleges are Engineering and Technology, Pure and Applied Sciences, Health Sciences, Agriculture and Natural Sciences, and Human Resource Development. Since its inception, JKU Art has been at the forefront in fostering a culture of research and innovation among faculty and students. The university's modern teaching and research infrastructure, as well as a blend of local and internationally sourced innovative students and qualified faculty, gives JKU Art an edge in facilitating the attainment of Africa's development aspirations. Besides, JKU Art is proactive in Africa's development mainly through various research initiatives. In 2012, for example, JKU Art won a competitive bid to host the Pan-African University Institute for Basic Sciences, Technology and Innovation, a graduate hub that has thrust JKU Art at the center of Africa's integration and development through graduate training and research. The establishment of various centers of excellence through its extensive collaborations and partnerships with government, academia and industry has been instrumental in supporting incubation of research into viable commercial ventures that are beneficial to society. Due to this, more top-notch research enterprises at JKU Art have earned the university a much-needed prestige not only in Kenya but in sub-Saharan Africa. JKU Art is, for example, home to the Legume Center of Excellence for Food Nutrition Security, Cassava Virology Lab, EU-funded Food Fortification Lab, and Innovation Prototyping Center, among others. JKU Art is also host to the China-funded Sino-Africa Joint Research Center, which has been at the forefront in advancing biodiversity research and conservation in the continent. In addition, JKU Art is home to Africa's only international maritime technology cooperation center fronted by International Maritime Organization to champion research in the emerging blue economy. With an enrollment of over 35,000 students, JKU Art is currently repositioning as Africa's leading entrepreneurial university. Jomo Kenyatta University of Agriculture and Technology is guided by a clear vision as a university of global excellence in training, research, innovation, and entrepreneurship for development. The university has a diversity of academic programs, research and innovation enterprise. JKU Art has 5 colleges offering over 400 academic programs. The colleges are Engineering and Technology, Pure and Applied Sciences, Health Sciences, Agriculture and Natural Sciences, and human resource development. Since its inception, JKU Art has been at the forefront in fostering a culture of research and innovation among faculty and students. The university's modern teaching and research infrastructure, as well as a blend of local and internationally sourced innovative students and qualified faculty, gives JKU Art an edge in facilitating the attainment of Africa's development aspirations. Besides, JKU Art is proactive in Africa's development mainly through various research initiatives. In 2012, for example, JKU Art won a competitive bid to host the Pan-African University Institute for Basic Sciences, Technology and Innovation, a graduate hub that has thrust JKU Art at the center of Africa's integration and development through graduate training and research. The establishment of various centers of excellence through its extensive collaborations and partnerships with government, academia and industry has been instrumental in supporting incubation of research into viable commercial ventures that are beneficial to society. Due to this, more top-notch research enterprises at JKU Art have earned the university a much-needed prestige not only in Kenya but in sub-Saharan Africa. JKU Art is, for example, home to the Legume Center of Excellence for Food Nutrition Security, Cassava Virology Lab, EU-funded Food Fortification Lab, and Innovation Prototyping Center, among others. JKU Art is also host to the China-funded Sino-Africa Joint Research Center, which has been at the forefront in advancing biodiversity research and conservation in the continent. In addition, JKU Art is home to Africa's only International Maritime Technology Cooperation Center, fronted by International Maritime Organization to champion research in the emerging blue economy. With an enrollment of over 35,000 students, JKU Art is currently repositioning as Africa's leading entrepreneurial university. Jomo Kenyatta University of Agriculture and Technology is guided by a clear vision as a university of global excellence in training, research, innovation, and entrepreneurship for development. The university has a diversity of academic programs, research and innovation enterprise. JKU Art has 5 colleges offering over 400 academic programs. The colleges are Engineering and Technology, Pure and Applied Sciences, Health Sciences, Agriculture and Natural Sciences, and Human Resource Development. Since its inception, JKU Art has been at the forefront in fostering a culture of research and innovation among faculty and students. The university's modern teaching and research infrastructure, as well as a blend of local and internationally sourced innovative students and qualified faculty, gives JKU Art an edge in facilitating the attainment of Africa's development aspirations. Besides, JKU Art is proactive in Africa's development mainly through various research initiatives. In 2012, for example, JKU Art won a competitive bid to host the Pan-African University Institute for Basic Sciences, Technology and Innovation, a graduate hub that has thrust JKU Art at the center of Africa's integration and development through graduate training and research. The establishment of various centers of excellence through its extensive collaborations and partnerships with government, academia and industry has been instrumental in supporting incubation of research into viable commercial ventures that are beneficial to society. Due to this, more top-notch research enterprises at JKU Art have earned the university a much-needed prestige not only in Kenya but in sub-Saharan Africa.
Thank you. We could just now move back to the presentation. PowerPoint. Let's go down. Thank you. So that video gives you an overview of how what the landscape looks like. It talks about how only a third of the population are connected to mobile broadband. It is more or less 4G coverage across Africa, which is actually the penetration is very low. If you look at it in Africa, most people are connected in mobile phones. So there's a lot of work that needs to be done in terms of accessing that technology. In terms of the businesses, you've seen how the pandemic just exposed how different people are marginalized. If you are not online, you're not able to get certain services. So that has created an opportunity in terms of where we can be able to develop. So what I'll do is I'll just move to the next slide. Thanks. Thank you. So what I'll do is I'll more or less bring up what the drivers are. What are the things that actually drive digital transformation? One of the key things is around infrastructure and platforms. What do I mean by this? Things like 4G network, things like fiber networks. Without that infrastructure in place, it's very difficult to be able to provide digital services, because those are the rails that are used as the backbone to be able to provide any solution, be it on a smartphone or computer. So these are things that the telcos are taking up. You'll see recently Safaricom and Airtel talking about 5G, which is more or less now going to drive things like IoT solutions. When you look at platforms, we're looking at government services. You can see that the government right now is really pushing all services to the platform called eCitizen. And it's not just happening in Kenya. I was in Zanzibar recently, and they're also driving their own e-government portal where they're going to have all government services on that platform and having their own payment gateway called Malipo. So they're all going towards providing services online, and the government is a very big contributor in terms of creating that behavior, so that people can get to learn and understand how to access digital services. The other piece is around financial services, being able to pay digitally. In Kenya, we're more or less the founders, especially around things like an M-Pesa. We have the Airtel money. And the other aspect is around credit. Businesses are really struggling around working capital. A lot of the SMEs, their key need is actually being able to access credit to buy more stock and be able to sell much more. The key other one that I'll elaborate a bit more on is on ecosystem partnerships. What do I mean by this? An ecosystem more or less is two different companies or products partnering to work together to provide a solution that you don't necessarily provide on your own. And I'll go deeper into that. Other things around policy and data protection. Anything digital requires data, and your data is personal to you. So you need to want to be able to protect your information and secure it. So all the solution providers have to be able to factor this in a very big way. It is a very big and sensitive topic in any segment or sector that is looking at providing digital services. The other is around customer experience. People want to access information, products in the most simple and most interesting ways. So the better customer experience that you provide. If you go to an application today and it has 10 steps for you to access the information you want, you simply close it and go to the next one that gives it to you in 2 steps. So that customer experience piece is very important. The other one is around human capital skills and development. People need to be able to be trained on how to use these services. If it's a business starting to use an inventory system for tracking their stock, the guy selling sugar on the street has no time for able to look for complex solutions. So we'll be able to train them on the simple solutions that are available out there. Then the last one is around access to technology, access to smartphones. Right now, I think the cheapest smartphone is probably around 6,000-7,000 bob, and that's a 4G device. That's why you see companies like Safaricom and others offering financing, so that the person at the bottom of the pyramid can easily access that device and access a much wider range of services. And the only way to do that is to make it more accessible and more affordable to them. So from a driver's perspective, this does not cover everything, but it more or less brings out the key areas or key drivers that are driving the digital transformation and innovation in Africa. Go for the next slide. So what I'll talk about here is technology trends. So what we're seeing is there are a lot of new technologies that are coming up as we move along. When I was growing up, we used to have a black and white TV. We used to have what called a video recorder. I don't know how many of you guys remember that. Some of you guys may not know what that is in this room. We used to have Walkmans. So those are some of the old technologies that are there. But now we're seeing things progressing much, much faster. We have things like 5G and IoT. 5G more or less is so fast that it will enable driverless cars, right? There's cloud computing, right? Before I do that, around the IoT solutions, there's a company in Tanzania called, it offers a privileged solution, whereby there's a company that has trucks that transport fuel. But along the route, their staff were stealing the fuel as it goes along. So what they did is they put in RFID sensors, and as they're able to track where the truck is, they're able to track if any of the ports where the fuel is dispatched is opened, and they're able to do this and see. They're able to see this real time, and it reduces that people stealing the fuel. Then there's also waste management solutions that have been used by the county in Nairobi, just to be able to track and see how the trucks are collecting the garbage and so forth. Around cloud computing, we're seeing a lot of people coming up, a lot of companies putting up data centers. So we have most of the telcos, MTN, Safaricom, Airtel, all these telcos are putting up data centers locally. What that does is that also with all the data privacy laws, there's a lot of requirement by governments to have the data on soil or in country. So in as much as they're providing cloud solutions, they do not want that data being processed outside of the country. So that's why a lot of the telcos are doing this locally. And what this does, it allows infrastructure as a service, platform as a service, and software as a service. So as you are building solutions here in JKUAT, you don't have to buy the server, you don't have to host the software yourself. Go to Safaricom or any of the telcos and then host all of that for you. You just focus on building the solution and providing the use case to the customer. So they remove that headache of investing that capex or that capital expenditure from your side. There's AI and machine learning. There was a recent AI conference in Kenya the other day, offering all kinds of solutions that are out there. There's one by Sun Culture that provides a AI-powered solar irrigation system. It provides so much information around the moisture of the soil, the temperatures, and that way the farmers are able to make informed decisions in advance. So this is out there, and to be able to simplify some of these things and to be able to enable the developers integrate to the different partners in the ecosystem, it's done through API integrations, which more or less allows the connection of different applications and transmitting of data real time. So there's quite a number of trends going on out there, and it's important to keep up with them because there's an impact in terms of how you're able to deliver a solution or digital solution to the market. Can we move to the next slide? So like I did mention about digital ecosystems. Now ecosystems are very important because it enables a developer or an entrepreneur to leverage infrastructure that is there existing from other industries or other sectors, right? So you're able to connect to a different company, you're able to access their solutions, and some of the benefits here is you're better prepared for economic change. A good example is during COVID. For example, Uber was primarily for just transport, but there was need for people to order food online, and Uber Eats came out of that. They had the technology, they had the infrastructure, they had the logistics through the riders, right? All that was in place. All they needed to do was start a different use case and bring in restaurants onto the platform, right? That's two different ecosystems. So they have the Uber tech, and the restaurants were looking for a way to deliver that food to their customers. The boda guys were there looking for business. They plug in and they're able to make money by delivering the food. That is a simple ecosystem that exists today. You're able to build loyalty, right, and quick revenue streams. You're able to also lower your customer acquisition costs. So, for example, even the boda, by the time he gets to build or know customers who are not on the platform, it will take time. But through these platforms, they're able to deliver to multiple people, right? Even people they did not know initially. So his cost of acquisition is very low. Then for the people like the platform owners, they're able to access customer analytics and data. And what this does is they're able to see the trends. What is the behavior? Are there guys who are buying more alcohol and in which area? Are there guys who are buying more fast food? Are there guys doing groceries? They're able to map it based on location. And based on that, they're able to make very unique offers and products that they can be able to offer to their customers. And let's go back. And what I've done here is, I just wanted to show a simple one, which is Glovo. If you look at the Glovo app there, you can see they have markets, they have food, they have pharmacies, they have drinks, they have shops, and then they have a center there, anything, where you can customize and say, this is what I'm looking for, and they look for a merchant to provide it. Glovo they don't own any of these channels. All they do is provide the tech and the platform to do so, and they get the channels to sign up with them, right? So that way, they have built, they actually survive or they thrive based on an ecosystem of different channels and different partners. This is quite a good example. When it comes to payments, and people can pay using different things. You can pay by M-Pesa, you can pay by card, you can pay by cash. So it covers so many things, and that is how they're able to thrive and to grow. So if for example, a supermarket try to do this on their own, with their own app, it's so much heavy lifting. You have to own the tech, you have to get developers, you have to get support teams, you have to get banks. It's a lot of work. But just by plugging into this, you're able to access the online space. Can move to the next slide. So just the other piece on the financial services. And there are different things around here. So one is about making and accepting payments and being able to cover different spectrums of the market. In Africa, mobile money for sure is king after cash. But from a digital perspective, mobile money is more or less what is driving digital payments, from enabling you to pay and for a kiosk or an outlet to receive payments. In terms of the larger international scope, people come into the country, they're able to pay using card, they're able to scan a QR and be able to make a payment. And then we have the big boys like Google and Apple who have Apple Pay and Google Pay, whereby once they launch in the market, all you need to do is go to your Google Wallet and make a payment in whichever outlet that you go to. Then, of course, for online payments, We have people like PesaPal in the region who are in multiple countries in Africa. They enable you to pay for online, whenever you make something online, they provide the gateway for that merchant to receive payment using mobile money, Visa, MasterCard, M-Pesa, and a variety of other payment options. So this space is very important, one, because it drives digital commerce. It drives the digital economy. You can be a small kiosk, you don't need to have a website, but you can still receive payments via card as well. You get in the queue right now, if you go for Masai Market, they don't need to have a PDQ. They can be able to generate a link, send it to the tourist puts in his card number and is able to make the payment. So you see, they're also driving business for the guys in the informal sector. The other piece is around credit solutions. You've seen people, it's very difficult for the informal sector to get loans. And that's driven by transaction history. The bank, if you don't have a bank account that you use a lot, they'll not be able to see your turnover, so they don't lend. But with digital payments, just by you consenting to offer your digital payments transaction history, people like KCB, M-Pesa, M-Shwari, MTN, Carbon in Nigeria, they can now just do a quick score and say you qualify for $200 and repay it within 7 days. So this is also driving a lot within the informal sector in terms of credit and driving business. The last one I want to talk about on this front is value-added services. What I mean by this is, there are a number of needs that small businesses have, things like cash management, inventory management, but some of the tools out there are very expensive. So what has happened is there are players or fintechs that have built solutions for these SMEs that for a small fee to get an inventory management solution, they're able to get a cash management solution, they're able to get credits within that platform as long as you trade within it. And this is driving a lot of commerce and business. And there are players, for example, in Nigeria called Alazo that is doing this, and one that is also in Kenya working with people like Unilever to supply, to enable that within their value chain in the distribution. So the retailer can be able to get credit from the distributor and be able to get more stock and to sell much more, and able to track the inventory. And based on that digital history again, they can be able to access credit services. So from a payments as financial services, it is quite broad, but I've just broken it down in those 3 areas and showed a few examples of what we see there. So as I finalize, there's what's called digital inclusion. There's a marginalized segment, people who who have been left out in this space. One, because either they don't have access, or the players, so the ecosystem does not want to deal with them because they don't have the records. So there's a solution that we've built at MasterCard called Community Pass, focuses on the farming value chain, whereby we link the farmer to the buyer. What that does, it helps them get value for their product. It helps build a transaction history. What that does, again, it helps them get access to credit, helps them get inputs at a good price, right? And that way they're able to build that, they're able to access digital payments as well. They can get a digital identity with a card that works offline and online. And that way they're able to be brought in and not feel excluded in the digital economy. So I'll just ask for you just to play the video. It's about 4 minutes long, and then I'll wind up.
By increasing the income from his crops. Then He can pay for his children's education and support his village. Isaac would like to know how he can respond to unforeseen expenses or emergencies. But today, Isaac is invisible to service providers who want to reach him. He may be eligible for government benefits, but has no easy way of accessing them. His local bank is unwilling to lend Isaac money or to invest in his business because there is no digital record of him, and Isaac has little control over how much he is paid for his crops and when. But there is a solution. Community Pass, powered by MasterCard. Isaac's farmer group is part of the Community Pass ecosystem, and they enroll him. He consents to add his relevant information into a secure application and register his biometrics. He then receives a Community Pass card. The farmer group agent explains to Isaac that his biometric information is secure. This information is not stored anywhere, and each time he uses his Community Pass card to access any service, he will be asked for his biometrics so that no one else can pretend to be him. Isaac is relieved to know that he doesn't need a mobile phone to use Community Pass, as his family shares the same phone, which often runs out of battery or data. With Community Pass, Isaac is now visible and accessible to any service provider that Isaac consents to. With Isaac's approval, relevant elements of his Community Pass profile are shared with his local bank. Using this data, the bank decides to lend Isaac money. This will help Isaac buy the quality seed and fertilizer he needs at the start of the growing season when cash is normally at a low. This means Isaac can grow more maize and earn more money to support his family and community. When Isaac takes his maize harvest to the farmer group, he confirms his crop value by tapping his Community Pass card and providing his biometrics. This reduces the likelihood of any disputes or fraud. It also ensures that Isaac will get paid the right amount. Isaac is paid instantly to the account issued by his local bank, and the money is available on his Community Pass card. This is much quicker and safer than cash. Now, at any merchant participating in Community Pass, Isaac can tap his card and biometrically verify himself to withdraw his money, buy goods, and pay his children's school fees. He can also check his balance, set aside savings, and receive subsidies or government disbursements onto the same Community Pass card. The merchant is also happy because Community Pass gives him new revenue streams and creates more loyalty with his customers. When Isaac is paid for his maize, his outstanding loan amount is automatically deducted. Because he's such a good customer, the bank is happy to lend to Isaac again and offer other services, such as crop insurance or loans to rent better equipment. Community Pass enables public or private organizations to know Isaac through his new digital identity, to reach Isaac through his Community Pass card and the Community Pass points of interaction, and to verify him through the Community Pass biometric solution. This shared infrastructure significantly reduces the costs of providing Isaac and other marginalized individuals secure, offline, life-enhancing services. And organizations can do this with confidence, knowing that the platform offers world-class privacy and security standards, enabling the responsible use of data insights. That's Community Pass, powered by MasterCard.
So then we'll just move to the next slide. So in summary, how digital transformation happens with innovation and ecosystems. One, identify the pain points and the key drivers that make an impact on people's lives. Apply the existing and emerging technologies to meet relevant needs. So build your solutions around those technologies so that they are relevant and they are up to date and able to offer much more unique services and use cases to the consumer. A multi-stakeholder approach to drive collaboration and build the right and relevant ecosystems. So you can't do it on your own. Look for the right partners, build the case together, and that will be able to offer solutions that you'd not have been able to do it on your own. Then drive digital economy through digital movement of cash. So look at digital payment solutions that make sense. It could be mobile money, it could be card payments, and that way you're able to create a digital history and a digital footprint that can help you access credit. And then now also include the marginalized communities into the digital economy. What that does to uplift their lives and also uplift the country and the continent as a whole. So that is what I had for you today. I hope I've added value to you and you've learned something new. And once again, thank you for inviting me here today. It's a pleasure. And I wish you all a great rest of the week of the function and a great weekend and happy Easter. Thank you.
Thank you, Bwana Eric, for your stimulating presentation. It's interesting to see MasterCard also going into the lower income communities to enable them to access credit beyond the normal M-Pesa and M-Shwari offerings that we get. I'll have a chance for just 2 questions, and please, they should be brief. No stories, brief.
Okay, much. A very interesting segment. My question is, now that you are having that product with you, has it been rolled out in Kenya? Is it effective? As extension workers, can we now take it to the communities? Can we have it as an option that we provide communities when they come to JKUAT, when they come to the organization and they want access to 1, 2, 3 things, because we have so many innovations that we want to give them. But one of the main challenges is they lack capital. Number 2, when you give them that, the community pass, do you also sit down and give them training on finances so that they can sort out their in-house finances and they can understand now what they're dealing with and how money now is the currency?
Great, thank you for your question. So I didn't get your name. Lydia, thank you for that question. So your question is, yes, we have launched it in Kenya, in Tanzania, in Uganda, and we'll be going to other countries as well, Ethiopia and the rest. In Kenya, the model is we work through our banking partners. So right now, in Kenya, we are working with Cooperative Bank and Equity Bank. So it is available. The reason we do that is we work with the aggregators. So for example, if it's coffee, a lot of them bank with the Cooperative Bank and they have very many farmers in their ecosystem. So the reason we work with the bank is that they can now come in and provide that funding because one, they can see the transaction history. So that from the credit side of things, that's done. On the training, yes, we have teams on ground that actually do the training. We do financial literacy training. We train them on how the system works, the value add that they get by working through this, because there's, I don't know whether there are middlemen in the room, but the middlemen are reduced in terms of that value chain, so they get more back for their crop. Yeah, so we do offer those 2 things.
Who are seated. My name is Simon Katagia, and my question is, some time back we had some phones that we had been told to put another screen because the radiation is a bit harmful. I have heard you mention something to do with the health there. Could there be bodies that are seeking to see how effective the radiations are, and to what extent, now that we have Kenya Bureau of Standards, that in Kenya it regulates so many things. In terms of such radiations, what standards are actually used?
Okay, in terms of devices, so one of my previous hats when I was at Safaricom is I was leading their device business. Now, one of the key things in that role is to make sure that before any device Safaricom sells, it has to be type approved by CA has a very strict type approval process. Before any manufacturer sells a device here, they have to go through a type approval process with them, and CA has to be able to test that device and issue them a type approval certificate. So based on that, the devices that are being sold should meet the set standards by CA.
Thank you. What I'm going to do is to ask Professor Nick Wanjohi to please humbly rise up. And as you ask and talk to Bwana Eric, you give him this gift in appreciation for your very active participation in the last 2 days. Yes. Yes.
So, I want to ask a question, because this seminar is about industrialization. And what I have heard is very good presentation on how people can use systems and instruments and the rest. That is use, that is consume. When will you start training people how to make these devices here, so that Kenya now becomes the supplier of these devices in Kenya, in Africa, in the world? In Kenya, we have all the material, raw materials, natural raw materials for all these devices. I don't think there is one material we don't have in Kenya. So when will you, MasterCard, start getting Kenyans to start making, that is what we call manufacturing, that is getting the material from the ground, processing it, producing parts, and start assembling, and then getting them to the market?
Thank you for that question. So MasterCard is a financial services technology company. We focus more on the financial services sector. We're not on the device manufacturing side of things. However, we do enable payments within that ecosystem of devices. So on that front, we are working with multiple device partners in terms of enabling payments. So when you look at things like contactless payments, we are enabling people to pay instead of buying an expensive PDQ machine. We are partnering with the manufacturers of devices to enable someone just to tap their card, so that the merchant, as long as they have a phone, you can turn that into an acceptance device, and someone can just tap their card and make a payment. So we're not on the device manufacturing side. We're an enabler offering valid services on top of that.
Thank you very much. We need to close. We need to close. So Steve, I think we'll stop there. So you can talk to Eric after the please. So shall we go up and then take notes? Professor Kwanza to please hold on because he still has more to receive on behalf of himself and others. So the next is for himself as the host of the conference. So sorry. So I also understand that there are gifts for the other DVCs, so he can receive on behalf. We also have a gift for the former Vice Chancellor. Professor Nick, please. Oh, sorry. Yes, I would like to invite the deputy. Please don't go far. We also have something for you. Yes. And after we give the gifts to our friends from Finland, the Deputy Vice Chancellor will proceed. So thank you. So. Yeah, paparazzi tells me to repeat the first photo, so please, Prof. Yes. So, yes. All right. Shall we bless it so that it accepts? Aha. Okay. So thank you. Thank you. Thank you.
Okay. I want to start by thanking the team from Finland for giving us gifts. Thank you so much. We feel like we have traveled to Finland because you'll be seeing what you have given us from all the way from Europe. To our Chairman of Council, Dr. Micah, I want to start by thanking you so much. You have been with us since yesterday, and we don't take it for granted. We appreciate you are very committed to the activities and to the success of this university, because this is one of the major events in the calendar of this university. We are aspiring to be a research university and entrepreneurial university, and therefore we feel supported from the top. When the chair of council has been with us, the full council has been with us, so we appreciate and thank you very much. I would also like to thank Professor Nick Wanjohi. Professor Nick Wanjohi, as was said yesterday, is the father of innovations in this university. And I think those of us who have been with listening to him since yesterday, every time he talks, 2 words. He is not missing those 2 words. And I know the audience can even tell me which those 2 words. I'm a teacher, but I'm not going to ask you questions. Tools and machines. In his presentation yesterday, he said for us to industrialize, we need to make tools and also make machines so that we are able to produce or to take production so that we produce whatever products we want to produce en masse. I would also like to thank the team from Finland. You have been with us. I think Chair of Council, this team did not come yesterday when most of us saw them. They have been here. I think I met them. Professor Meso, was it on Monday or Tuesday? This week. Actually, it's like they have been here this week. They are doing a lot with us. We are doing projects with them, research projects, and they are also supporting our students to acquire higher degrees, masters and PhDs. Already we have one, but I'm not seeing him in the room today, but yesterday he was here. Thank you so much. Professor Wanjohi, thank you so much. And then all the presenters, keynote presenters. I think we have learned a lot from the keynote presenters since yesterday. Presentations about science, technology, and industrialization generally. And I think all the presentations have been very informative, very enlightening, and we have been wanting to ask more and more questions, but we have been limited by time. Actually, there is no presentation for which there were no questions. The questions for each keynote presentation were overwhelming. And I think that tells us that we were getting what we were expecting from the keynote presenters. Thank you so much. Again, all the presentations which were being made in various specialized areas. I took time and went around, sat in some of them, especially the engineering and also the basic and applied sciences, and a little in agriculture. And I can tell you all the presentations were very informative. Even for those presentations, the chair and the reporter were limiting the presenters because the audience were having more questions to ask. So thank you very much to the presenters. I want to thank all the participants who are with us physically and who are with us online. Chair of Council, I think it's important to mention this, that we had participation from 16 countries. We had, we had participation from people in Germany, in Japan, in India, and Togo, Algeria, so many African countries also. But in total, the participation was from 16 countries. And also we had participation from 52 institutions. There were a lot was happening online, so we have that data with us. So I think this was truly an international conference. So thank you so much. I know you are tired having been here since yesterday to now, and I don't want to say much more. At this juncture, it's now my pleasure to invite our chairman of University Council to close this conference officially. Welcome, Dr. Micah Onsando, chairman. That is not how we welcome people in JKU. You know, we have patented 5 factorial. So let's start. 1, 2, 3, start. Thank you very much. There was no supplementary. Thank you.
To talk to you this afternoon, the Vice Chancellor, Professor Victoria Wamboi Ngumi, the Deputy Vice Chancellors present, principals of different schools present, heads of departments, invited presenters, exhibitors, other distinguished participants, staff and students, ladies and gentlemen. As we come to the culmination of the 18th JKU Scientific, Technological, Industrialization Conference exhibition, I am filled with gratitude and sense of accomplishment. The gathering has been a testament to the power of collaboration between academia, industry, and government in driving sustainable development. First and foremost, I must extend my heartfelt appreciation to the organizing committee, whose dedication and tireless efforts have brought this conference to fruition. Your commitment to advancing knowledge and fostering academic excellency is truly commendable. And it underscores the university's unwavering dedication to the pursuit of excellency. By the way, it's important to mention that currently we stand as number 2 nationally and the number 6 continentally. Can we clap for ourselves? Over the past 2 days, we have had the privilege of hearing from a diverse array of participants, including esteemed representatives from academia, government, and the industry, both locally and internationally. And maybe at this juncture also to add that this meeting was truly international, as 16 countries were represented. The depth of insights and the quality of discourse that has been generated during the conference has been nothing short of exceptional. The theme of the conference, fostering quality training, research, innovation, and entrepreneurship for sustainable development, could not have been more pertinent and relevant to today's rapidly evolving world. The discussions and ideas that have been shared here will undoubtedly serve as a catalyst for driving sustainable development across various sectors of our economy. I'm particularly delighted to see the significant representation from various African nations and beyond, which speaks volumes about our growing stature as a global hub for research, training, innovation, and entrepreneurship. The impact of this conference cannot be overstated. It has reignited the spirit of collaboration among researchers and institutions, transcending disciplinary boundaries and geographical constraints. It is through such collaborative endeavors that we will find the solutions to the myriad challenges facing our society. Before I conclude, I must acknowledge the immense challenge of organizing an event of this magnitude and express my profound gratitude organizers and all the participants for their collective efforts in making this conference a success. As the conference comes to a close, I urge all participants to leverage on the networks established here, particularly within the private sector, to translate research findings into impactful solutions at scale. Furthermore, I implore researchers to engage closely with policymakers to ensure their findings inform evidence-based policies aimed at driving socioeconomic progress. It's my honor and privilege to officially now declare the 18th JKU Art Scientific, Technological, and Industrialization Conference and Exhibition officially closed. Thank you all for your invaluable contributions. I look forward to witnessing the transformative impact of the ideas generated here today. Thank you so much, distinguished ladies and gentlemen.
So thank you, Chair, for your very warm words. I believe the team has taken this to heart, and we shall continue leveraging on the networks, the lessons we've learned, and also to pick up on these issues and push them forward, especially what we had today and the day before, about Africans trying as much as possible to lead the Renaissance.
That should also ensure stability and power and is making the success of God. And with lessons learned and we will be blessed to know glory. In Jesus' name do we pray, trusting and believing.
After the chair
come here and extract through a rotational system where through this distillation unit and vacuum, then the solvents comes in and this will get last part.
Second thing was and for my sensor has highest preference.
Jomo Kenyatta University of Agriculture and Technology invites you to apply for degrees, masters, and PhD programs in the College of Engineering and Technology, COETEC. COETEC has 5 schools offering programs in the School of Mechanical, Manufacturing and Material Engineering, Electrical, Electronic and Information Engineering, Civil, Environmental and Geospatial Engineering, Biosystem and Environmental Engineering, as well as the School of Architecture and Building Sciences. The highly qualified, dedicated and experienced faculty at the college offer a conducive and participatory learning environment and is home to a diverse and vibrant student community. Over the years, the college has continued to produce competent, high quality, and innovative graduates who have made significant contributions to various sectors of our economy. With state-of-the-art teaching and research infrastructure, coupled with a strong culture of innovation, the college stands at the forefront, facilitating the realization of Africa's development aspirations. Great stories begin here. You too can start your journey to making your dreams come true by joining JKU Art. Applications are ongoing. To apply online, visit admission.jkuart.ac.ke. JKU Art, setting trends in higher education, research, innovation, and entrepreneurship. Jomo Kenyatta University of Agriculture and Technology invites you to apply for certificates, diplomas, degrees, master's and PhD programs in the College of Human Resource Development. We are here to equip you for the marketplace. The College of Human Resource Development has 2 schools and 5 departments offering diverse programs in the fields of business, entrepreneurship, procurement and management, as well as communication and development studies. At the JKU Art Center of Professional Studies, we offer CASNEB, HRMPDE, and the KISEP professional courses. Over the years, the college has continued to produce competent and innovative graduates who have made significant contributions to various sectors of our economy. Driven by a strong culture of innovation, the college stands at the forefront of facilitating the realization of Africa's development aspirations. Our highly qualified, dedicated, and experienced faculty at the college offer a conducive and participatory learning environment and is home to a diverse and vibrant student community. Great stories begin here. You too can start your journey to making your dream come true by joining JKU Art. Applications are ongoing. To apply online, visit admission.jkuart.ac.ke.